Excellencies, honorable guests, online and on-site participant, ladies and gentlemen.
Assalamualaikum warahmatullahi wabarakatuh.
Peace be upon us all. Good morning, and we are delighted to welcome you all in the International Conference on Smart Computing, IoT, and Machine Learning with the theme Advancing Intelligence and Connectivity, Innovating in Smart Computing, IoT, and Machine Learning. Ladies and gentlemen, allow us to introduce ourselves. I am Akila Nailanur.
And Dimas Setiti Rahman as the Master of Ceremony of IEEE 2024.
Now let us begin the IEEE 2024.
Before that, we would like to read out the rundown. First, we have the opening.
Second is Tilawah of Holy Quran.
Third is singing national anthem and Muhammadiyah anthem.
Fourth, we have a welcoming speech from a general chairman.
Fifth, we have a welcoming speech from the Dean of the Faculty of Communication and Informatics Universitas Muhammadiyah Surakarta.
Sixth, we have our first keynote speaker carry on with our second keynote speaker.
Second, we will have a break time.
Eighth, we will carry on with our third keynote speaker.
Next, we will have the parallel session.
And then we have the announcement of the base paper.
And the last is the closing. And for the next agenda, we will have a brief moment for a tilawah of the Holy Quran by Zildan Al-Fatih Agustian and Maulana Al-Iqbal Widodo. To Zildan Al-Fatih Agustian and Maulana Al-Iqbal Widodo, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. Lillahi ma fis samawati wa ma fil ard. Wa in tubdu ma fi anfusikum aw tukhfuhu yuhasibakum bihillah fayaghfiru liman yasha'u wa yu'adzibu man yasha'u wallahu ala kulli syai'in qadir. Unzila ilaihi min rabbihi wal mu'minun kullun amana billahi wa malaikatihi wa kutubihi wa rusulihi la nufarriqu baina ahadin min rusulihi wa qalu sami'na wa ata'na ghufranaka rabbana wa ilaikal masir. La yukallifullahu nafsan illa wus'aha laha ma kasabat wa 'alaiha maktasabat. Rabbana la tu'akhidna in nasina aw akhtana. Rabbana la tahmil 'alaina isran kama hamaltahu 'ala 'alal ladina min qablina. ربنا ولا تحملنا ما لا طاقة لنا به واعف عنا واغفر لنا وارحمنا أنت مولانا فانصرنا على القوم الكافرين صدق الله العظيم.
To Allah belongs whatever in the heaven and whatever is in the earth. Whether you show what is within yourself or conceal it, Allah will bring you to a comfort. Then He will forgive whom He wills and punish whom He wills. And Allah is over all things competent. The messenger has believed in what was revealed to him from his Lord, and so have the believers. All of them have believed in Allah and His angels, and His book and His messenger, saying, we make no distinctions between any of His messenger. And they say, we hear and we obey. We seek your forgiveness, our Lord, and to you is the final destination. Allah does not change a soul except with that within its capability. It will have the consequence of what good it has gained, and it will bear the consequence of what evil it has earned. Our Lord, do not impose blame upon us if we have forgotten or earned. Our Lord, and lay not upon us a burden like that which you laid upon those before us. Our Lord, and burden us not with that which we have no ability to bear, and pardon us and forgive us and have mercy upon us. You are our protector, so give us victory over the disbelieving people. Wassalamualaikum warahmatullahi wabarakatuh.
And Maulana for giving us the reciting Quran. Up next, we would like to invite you all to rise and sing Indonesia Raya as well as Sang Surya. So to all of the participants, you may all please stand up.
Salam
To all of the audience, you may all sit back down.
Now we are going to listen to the welcoming speech from the General Chairman of IEEE 2024. Please welcome Gunawan Arianto, PhD.
Ladies and gentlemen, distinguished keynote speakers, esteemed colleagues and friends, Assalamualaikum warahmatullahi wabarakatuh. Good morning and very warm welcome to the 2024 IEEE International Conference on Smart Computing, IoT and Machine Learning. It's my great honor and privilege to stand before you today as the General Chair of this event. This year's conference, hosted in the vibrant city of Surakarta at the Edutorium Universitas Muhammad Surakarta. This marks a significant milestone as we gather both in person and virtually to explore the frontiers of technological innovation. The theme of our conference is Advancing Intelligence and Connectivity, Innovation in Smart Computing, IoT, and Machine Learning. This reflects the rapid advancement and the transformative potential of these fields. Our world is increasingly interconnected, and the integration of smart computing, IoT, and machine learning is driving the unprecedented changes across industry, from healthcare and transportation to environmental sustainability and beyond. I'm delighted to share with you that we have received 128 full paper submissions. Yeah, you can see the statistic here. And we accepted a remarkable 57 accepted papers, covering extensive range of topics within our conference theme. So we have around a 45% acceptance rate for this year's conference. These papers are organized into three main tracks, as you know: the Internet of Things, smart computing, and machine learning. Additionally, we are proud to have participants from 9 countries, including the United States, Germany, China, Italy, Malaysia, Japan, Russia, Iraq, and of course, Indonesia. So this global representation underscores the international scope and collaboration spirit of our conference. We are also excited to feature keynote addresses and panel discussion that will provide deep insight and foster engaging discussion. Our goal is not only to share knowledge, but also to inspire collaboration and drive the development of new ideas that will shape the future of smart computing, IoT, and machine learning. I would like to extend my heartfelt gratitude to our partners from another universities who becoming committed together with UMS, and also the organizing committees, the scientific committees, and all of the friends here for their support and dedication. Without their effort, this conference wouldn't have been possible. I also want to thank all of the authors and presenters for their contribution and the attendees for joining us on this intellectual journey. As we embark on this conference, I encourage you all to engage actively, share your insights, and explore the opportunities for collaboration. Let us take this time to learn from each other, build new connections, and pave the way for advancement that will benefit society as a whole. Thank you again for being here, I wish you all fruitful and inspiring conference. Welcome to SIML 2024. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Gunawan, for the welcoming speech. Next, we are going to listen to the welcoming speech from the Dean of Faculty of Communication and Informatics, Universitas Muhammadiyah Surakarta, to Mr. Nurgiyatna, PhD. The place and time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin. Allahumma shalli wa sallim wa barik ala sayyidina wa maulana Muhammadin wa ala alihi wa ashabi ajma'in ba'd. All praise is due to Allah, the most gracious, the most merciful, and may peace and blessing always be upon our Prophet Muhammad sallallahu alaihi wasallam. On behalf of the Fakultas Komunikasi dan Informatika Universitas Muhammadiyah Surakarta, it is with great pleasure and enthusiasm that I welcome you all, the keynote speakers, the presenters, the participants to the 2024 SIML, the International Conference on Smart Computing and Machine Learning. We are honored to bring together a such group of experts, innovators, and scholars from around the world to discuss the latest challenges and advancements in this dynamic area. Our conference this year is very exciting since we discuss about the most transformative areas of smart computing, Internet of Things, and machine learning that is support the contemporary technology. So these areas are at the forefront of driving innovation and shaping the future of technology, impacting industries ranging from healthcare and transportation to agriculture and urban development. The 2024 SIML features a robust program that includes keynote addresses by leading figures, innovative and cutting-edge research presentation. We are proud to offer where scholars share their findings, exchange ideas, and foster collaboration. I would like to extend my gratitude and appreciation to organizing committee, the reviewers, our sponsors, and the volunteers who have dedicated their time and energy to making this conference a reality. To all the keynote speakers, authors, presenters, thank you for your invaluable contribution. Your research and insight are the cornerstone of this conference, and it is through your dedication and innovation that we continue to advance and explore new frontiers in smart computing, Internet of Things, and machine learning. As you participate in this conference, I encourage you to engage actively, seek out the opportunities to build connection that will last beyond this conference. May this event be a catalyst for new ideas, collaboration, and advancement that will shape the future of our field. Thank you for joining us in this conference, and I wish you all an inspiring, productive, and enriching experience. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Nurgiatna, for the welcoming speech. It is an honor for us to introduce and welcome our keynote speakers at this conference. First, we have Professor Ahmad Beni Mutiara from Universitas Gunadarma, Indonesia. Second, we got Professor Valerio Basile from University of Turin, Italy. And third, we got Husni Tamrin, PhD from Universitas Muhammadiyah, Surakarta, Indonesia.
All right, honorable guests, online and on-site participant, ladies and gentlemen, moving on to our first keynote speaker, Professor Ahmad Beni Mutiara, which will be moderated by Dr. Endah Surdamila. To Ms. Endah Surdamila, we welcome you to the stage.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning all, and maybe I greet to Professor Ahmad Beni Mutiara in there in this platform. Assalamualaikum, Prof. Okay, but the sound is okay. Assalamualaikum, Prof.
Waalaikumsalam.
Okay, so the sound is clear here, Prof. And good morning, all. The Honorable Prof. Ahmad Beni Mutiara, our speaker, our distinguished participants, and ladies and gentlemen. I introduce myself. I'm Endah, and it gives me pleasure that I to be moderator here, and for our keynote speaker. This is the first keynote speaker. That's Prof. Ahmad Beni Mutiara, and have a famous name as Prof. Aben, like that. And now. I introduce for our keynote speaker. There is as we know, Prof. Aben is it's like we know he is a researcher from Gunadarma University, and now he is chairman of Association for Computer Science in Indonesia, Apticom. And also he is an assessor member for LAM Infocom, this independent accreditation institution for computer science. And Prof. Ahmad Beni Mutiara, Prof. Aben, have many research about computational technique, and today he will deliver to us about implementation of convolutional neural network with efficient B0 architecture for brain tumor classification. Okay, and before the presentation begins, let me tell how it will run. Firstly, our speaker, Prof. Aben, will present the material. Is about 30 minutes. And after that, the session will be question and answer, and approximately 20 minutes. And the last is finally session will be ended by the conclusion. Okay, ladies and gentlemen, without further anything, now allow me to welcome Professor Aben, Professor Ahmad Beni Mutiara, to present the material about implementation of convolutional neural network with efficient B0 architecture for brain tumor classification. This for 30 minutes, Prof. And this time is yours.
Thank you very much, Mrs. Enda. Assalamualaikum warahmatullahi wabarakatuh. Honorable Deans of Faculty, I forgot the name, I think, and also Honorable General Chair, and also all distinguished participants. Please let me show you the presentation, my presentation. Can you see, I think? Is my talk is heard for you?
Yes, Prof.
Yeah, okay.
Thank you.
The title of my presentation is what is say here is the implementation of convolutional network, yeah, with efficient net B0 architecture for brain tumor classification. Why we choose this title? Because we have problem with the especially in health, yeah, in our health, also in my country, especially in Indonesia, there is no more. Also, there is not much research about this. I think it's about mainly the problem is about we have what we have, what we could have data set in the real data set in Indonesia. Also, this is interesting in health field, yeah, because this is very important for us, yeah, for our community especially, yeah. Also, brain tumor, there are one of the deadliest cancer, yes, and are difficult to detect. Also, in the early stage, also there are many types of brain tumor in Indonesia, as they vary in type and nature, yeah. Maybe there are benign and malignant brain tumor, and also main example of malignant brain tumor originate from the brain cell themselves, namely glioma tumors, yeah. And there are also other type of brain tumor. Here, namely, we can say that meningioma or pituitary. Also, if a brain tumor is detected at early stage, there is a high chance that surgery or other treatment will be successful. Yeah. Also, there are we use here that the use of image technology such as CT scan and MRI or magnetic resonance imaging does help detect brain tumor, but mainly diagnosis has shortcoming in terms of time and accuracy. So an alternative method that is faster and more accurate in detecting brain tumor is needed. Yes. Convolutional network is using here. I will use efficient net B0 architecture. So will be integrated with a website. I think we know that mostly using Python programming language, and then we can implement that in Flash framework. So in this case, the website will allow us, user to upload MRI images, and later detect a brain tumor type on the website. So with the implementation of this website, the classification can be used by general public and medical personnel in conducting early detection of brain tumor, and can expand the dissemination of information and education about brain tumor to the wider community on the importance of early detection of brain tumor. So the method here we are utilization in development, yes, software development life cycle, yeah, and then this research, especially we employ CNN modeling, but with efficient net B0 architecture for brain detection, yeah. Detection, especially also in MRI images. Also, there are involving steps here. So first, analyzing, and then designing and developing using libraries such as NumPy, and then Pandas and MATLAB, yeah, Matplotlib. And also we use OpenCV, Keras TensorFlow, and Flash. And the Flash is a framework to develop the model atau implementation the model in website, yeah. And then following by testing and evaluation of performance metric, likely like accuracy, precision, and recall, culminating the implementation of the train model into a website using Python and Flash, yeah. And then here our result and discussion, also data collection. Unfortunately, we have just used Kaggle source, yeah, here. We use a data set from brain tumor classification MLI, and we have here and use 3,264, yeah. This is unfortunately because it is not easy in Indonesia to get to find, also to gather the data set in brain tumor, yeah. So in the study, we have used a secondary data set from Kaggle. Means that we use a data set from Kaggle, yeah, brain tumor classification. And it is interesting that there are many people use this data set. So I think when the presenter or the participant will want to use the data set about the brain tumor, we can use the data set from Kaggle. After that, we have from this 3,000, we have to train the data set, yeah. So we have split the data set 80% for training and 20% for testing. Means that here classification maybe, so for training for glioma is 826, and then for normal brains, yeah, we have 395, and then meningioma is 822, and then pituitary is 827. For the testing, we can see that for glioma is 100, and then normal is 105, and then meningioma is 115, and then pituitary is 74, yeah. And then we have to pre-processing the data set, means also after completing data collection. Here means that the pre-processing involve cropping and resizing, means that to enhance feature extraction. Also with the cropping means that removing irrelevant image corners, and resizing, adjusting image size for analyzing. The data set comprising, as you said, 3,264 images is split into training 2,070 images, and the testing is 3,094 images. Assessed randomly means that to ensure the convolution network generalization ability. And we have to scaling the data, means that we reduce the image size, so from 150 times 150 to 75 times 75 pixel. Means this is using OpenCV, we can use that, and then NumPy and augmentation, including here also flipping and rotation is applied to prevent overfitting the data, yeah. Attention is aspect ratio is crucial, means that to avoiding significant distortion that could impact the CNL model performance, yeah. And then the model is can be show here that there are 9 convolution layer. So this layer is can be run a different way, yeah. For example, MB-conv 3 times 3 is 1, and then the other maybe, for example, MB convolution 6 is 5 times 5, yeah, 5 times 5 is 3 times, yeah. And then the closing is convolution is 1 mile once, yeah, is once running in once, yeah. And then and this is part of feature learning, yeah. And then the end of the feature learning is we have used layer pooling here. And then we run once, and then after that we can enter the classification block. Yeah, this is we use a flatten. Yeah, and then we applied fully connected network, and then after that we can use a softmax layer to classification. The output here are four classification. Yeah, the first is glaucoma tumor, and then maybe normal tumor, and then meningioma tumor, and then pituitary tumor. And this is our model. Yeah, and then the result is following. Yeah, that we have developed the model, and we import here the efficient net B0 architecture. So we have used a package from Keras. Yeah, means here we use the Keras point application package here, and then we initialize it with pre-trained weight from ImageNet. Yeah, exclude, and the fully connected layer, we added global average pooling 2D layers, and then we implemented a dropout layer with 0.5 rate, and then the last added an output layer with 5 units using softmax activation. Means that for generating class probabilities. The model is now constructed using TF-HAT model, and also take input from FNet input and then produce output from the defined model variable. Here, the model we have to evaluation. Yeah, means that we saw here the heat map of confusion network. Yeah, confusion matrix. Sorry, and then for the four classification, also glioma tumor, and then normal tumor, and then meningioma tumor, and then pituitary tumor. So we can also count, also calculated the precision recall here. And then we see that for glioma, the precision for glioma is 0.990. Yeah. And then normal tumor is 0.98, yeah, and then meningioma is 0.98, and then pituitary is 0.98. And then for recall, it means that glioma is the maximum, so the good, yeah, result is by pituitary is about 1.00. And then we also calculated F1 score. Yeah, this is glioma, and so most of result is 0.98, and then the last is we have calculated the accuracy. The accuracy is mean 321 by 327, means that the accuracy is 0.98. Yeah. This is the result of evaluation of model, means that the model is have good accuracy, means that also nearby 100, yeah, 100%. So here mean 98% accuracy. So here a comparative testing. Also, beside we compute the model, also the flop the model efficiency not be 0. We have also calculated also with other architecture. The first we have comparison with VGG 16. Yeah, with this architecture we have a precision about 91%, recall is 92%, F1 score is 92%. And then the second architecture we have tested also is inception ResNet v2. The precision is 97%, and recall is 98, and then F1 score is 97%. And the last is our model is efficient net B0 is the precision is 98%, recall 98%, and then F1 score is 98%. So we have also testing with the use of optimizer here, means that we can use here in our research. Our research is we can use ADEM or RMS prop here. So we can see that between ADEM and RMS prop, the ADEM is better than RMS prop. And then we have also made another scenario with EPOS, yeah, with optimizer ADAMS here. Also, the data here from brain tumor, we use optimizer ADAM. The best size is in this studies is used 3,022. The first testing with brain tumor with ADAM optimizer, we have EPO 21, yeah, 2025, sorry. And then the accuracy is 90.79%. And the loss here is 0.6567. Yeah. What the time is use is here 158 millisecond per step. Yeah. And then we have also with scenario with different epoch. Also, we have used here that we can have is the small epoch, yeah, with 15, yeah, with accuracy also 99.650, but the loss is very high, is 101.1527, yeah. But the time is average is 161 millisecond per step. So the second experiment with another epoch we have is 21. So as I said that we use here optimizer with ADAM, yeah. But the bed size still we use here 32, yeah. We can use another bed size, but here I think is better bed size that we can use in this model. Yeah. Another EPTO is we have here 25, and then the last is 30 epoch. Yeah. But with different epoch, we can see that the accuracy is very better. Yeah. 90, so near 100 here. And then here the implementation after we have a good model, and then we implementation that in Flash, yeah, and then we have a website here how to detect brain tumor here, and then here the menu is first you have choose the model, yeah, and then we can use the picture, also the image. And then the system is good running, yeah, and then can detect which can detect the brain the brain tumor itself. Yeah, here for example, that's the system can detect meningioma tumor with accuracy about 990.550. So I think this is very important for the implementation. That's this implementation can be used for our community, especially community in health. Yeah, community in health. Also, we can use maybe also can use the doctor. Yeah, so the art in especially in brain. Yeah, and then the last is a conclusion, means that. The research means that indicate the success of CNN method in predicting glioma and normal tumor, pituitary, and also meningioma tumor, also types on MRI images. And then we have utilizing a data set of 3,264 images, yeah. With the training test splits of 2087 and 3094 respectively. And then the model incorporating layers such as convolutional, and then base normalization, and then device activation and zero padding achieve a high precision, recall and F1 score value of about 980%. So during experimental scenario, also with efficient net B0 architecture outperforming others. Yeah. So the Flash-based website program demonstrate commendable accuracy in brain tumor classification based on MRI imaging. I think that I can say today, I'm sorry, I think we can sort as maybe the all participant maybe make experiment like this, yeah, maybe with other architecture. So as we know that this is a classical using of deep learning, yeah, means that we have used CNN and so on and so on. But maybe in the future, we can use maybe with LLM, yeah. Also LLM means that large language model, maybe they can use to or classification the brain tumor. Also, the future work is our research. Maybe we can use LLM. Yeah, mainly we can use the architecture for GPT-4 or GPT 4.5, or maybe we can use BET from Google. Yeah. Thank you for this session, for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. That was a very comprehensive presentation, Prof.
Yes.
Okay, ladies and gentlemen, after we know about implementation of convolutional neural network CNN with efficient net B0 architecture for brain tumor classification, now we have time for discussion with Prof. Aben. Maybe we now have come for question and answer discussion, and it will make, yes, Prof?
Yes, come on.
Okay, to make easier to answer the question, maybe we will, I will arrange, we will have 4 questions for participant, and I will divide to online participants and 2 for on-site participants. For online participant, maybe you can give the question for Prof. Aben with a raised hand, or you can text it on chat room. For the on-site participant, please feel free to raise hand. Come on. Any question about it? Maybe I'll...
The problem is very easy. There is no...
Okay, but this is we have a question on chat room, Prof. Maybe I will read it for you. This is... Okay, this from Mr. China Arifin. This research is about implementation of convolutional neural network with efficient B0 architecture for brain tumor classification. This for data processing is complex processing, how to process MRI images to ensure they are in the right format and size. Error in pre-processing can reduce model performance.
So thank you for the question.
Yes.
Yes. The first, we can use automatic tools. Yeah, they can arrange the domain, also the range of the size of image. Yeah, we can use. So we can also maybe this is very hard work. Yeah, we can use manually. But as we say here, that we use the data from Kaggle, I think the size is very good. Means that's what's the picture, also the image is soon better. Also is good. This is CG for us when we can develop data set itself. So for example, from hospital in Indonesia, this is not easy. Also in this research, maybe very easy and then very safety. When we have used the Kaggle, maybe the Kaggle is there is what's memorandum understanding about the use of this data. So the Kaggle can the data from Kaggle can be used. The size is very specific for deep learning. They can use a big data, so we must reduce that's about maybe not too big. And then we can say here I forgot that from big one to size that can be used for deep learning. We cannot use a big one in deep learning, but we can reduce one that can be accepted by deep learning. Also, we can say that we can manually or automatic resizing the image, but we have to know that the size must be based on our experience is about not too high. It's about the pixel. I forgot it here. It's about maybe the size is about you can see that about 75 times 25 pixel. So bigger as that maybe is too hard for the deep learning to understand the image. Yes. So in principle, not too big. So the main size is about 75 times 75. So smaller is better. Smaller is better. Maybe 50. But maybe when we have the picture or the image 150 times 150, it can reduce smaller, or maybe half, maybe about 75 times 7. This is our standard. I think the international know about this standard about utilization of deep learning.
Okay, thank you, Prof. Aben. Maybe Mr. Jainal Arifin, if
so we have testing. When a bigger one, we have overfitting.
Yes.
We have overfitting about the data.
Yes.
Maybe a smaller size is menghindari istilahnya the overfitting the data.
And also, Prof. Aben, maybe continue with Mr. Jainal Arifin question, and also in Prof. Aben's slide said that Prof. Aben have highlight about overfitting and on the pre-processing, right?
Yes.
And I'm eager viewer to know how about the threshold about it, and how the system will be have the tolerate for it.
Yes, maybe. What about overfitting? Overfitting is the running of graphic. That's not normally. Sometimes is maybe we can say normally all in for example 0.7 0.7, and then higher with maybe with the right slope. But sometimes they can make overfitting, means that the data is over, for example, sometime 0.9 0.9 is this overfitting. And then we have the not overfitting is maybe in the right slope. In the right slope, for example. When we have the line, yeah, maybe the trace. So the tracing of graphic is maybe the straight one, yeah. So with a good slope. Maybe another one, and then get expressionally, and then go to one. Yeah. Sometimes the data is not in the right track, and you can say this is overfitting. So when we use the images, the size of image is more than also maybe here 75 75 times 75, we can experience that make overfitting the data. Yeah.
Thank you, Prof.
Yes.
Okay. Maybe from another participants. I think this from Zoom. There is no more. Okay. For the on-site participant, any question about it? Okay. Come, maybe for the technician, give
No, that
the
is
microphone.
too easy for the participant.
But maybe
I
I'll
think-
have inspiration, Prof, for the
Yes.
future. Okay, maybe you can introduce.
Oh yes. Thank you for the opportunity. Introduce my name is Surakarta from IPS Institute Teknologi Provider. Thank you. Thank you. My question is does this research use image augmentation, image augmentation techniques, and how does it affect the precision of your research? Thank you, Prof.
Yes, also this documentation is that maybe to make the higher accuracy. Yeah. So sometimes MRI is not good. It's not easy, yeah, to classification because this is black and white. Yeah. And then means the augmentation means, for example, the edge detection is better, is making better, and also wider, and so on. Yeah. With the augmentation, especially, yeah, it can make more precision. Actually. So we have experiment without augmentation, the precision is lower than we have now. So the augmentation means we can use maybe as protection, and then the other image processing make the quality of maybe the image is better to this classification, yeah? And then after we have a good image after augmentation after the augmented image, it is easy, yeah? To detect classification, and then the precision is must be better than without augmentation. Thank you. So it is chemistry without augmented, but we have experience that it's not good in precision. Yeah.
Okay, thank you.
So
This is technical mistake.
yeah.
Okay, thank you, Prof.
More
Ahmed.
technically, yeah. Yeah.
Every mistake is for technical, bro.
Yes, yeah, technically one, yeah.
Oh my
We can
God.
make it augmented manually.
Yeah.
Sometimes we can make it automatic, but this augmented is very important, yeah, in this study, yeah.
Okay.
I have experience without augmentation, the precision is very lower, yeah. Then and also MRI is not easy one, yeah. Also maybe is need maintains better, yeah, yeah, about the MRI images, yeah.
Okay, thank you, Prof. What about Mr. Suharyanto? That's already. Okay, thank you.
Yes.
Okay, another participant have any question about it? Okay, thank you. Please give the microphone then. Still have a phone on-site participant, Prof. Have the
Thank you.
question.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thanks for a great presentation.
My name is Arisrapadi. I'm from Universitas Muhammadiyah Surakarta. My question is, can we change
a dataset of images with a dataset of video? For example, USG video, which widely used in medical devices. If yes, please advise to us what should we do to modify the result or modify the method. Thank you.
So, it's not easy for the deep learning use the video, I think, yeah. Maybe you can use ChatGPT or what. So my suggestion is maybe you can use not only deep learning but also LLM is better, yeah. Maybe LLM can we can the input of data by video maybe. So as long as we know that deep learning is still use images, yeah, without dynamic image or move image, I think, yeah. I think you can use for when we use the video data set, we can use LLM, yeah. Please, we have the last week, yeah, or maybe 2 weeks ago, yeah, we have a paper about how to classification using LLM. This is interesting. So this is classic one. Our research is classic one. Ya, jadi so deep learning is classic one. Maybe we can not more use about deep learning, but more advanced using transformers means you can use large language model. So we can say that maybe the research another person, the paper said that LLM can be used to classification of this image, yeah. When the LLM can use to LLM classification, we can use also better, yeah, in image in health field, yeah, maybe in brain tumor and so on. This is my suggestion, not use more deep learning, but use LLM, yeah, transformer, yeah. Especially when do you want to use video as a data set. I think, yeah, I've never experienced direct classification on video, but still that video is still recording as still image, not dynamic image. I think this is my answer. Yeah. Thank you.
Thank you, Prof. Aben. Okay.
It's not easy deep learning to the input deep learning as video. I have no experience about that.
Okay. Maybe for to continue from this question, Prof.
Yes.
I think there is many more to enlarge the research about it. What about the future research related with this, Prof?
Yes, the related is also maybe in informatic aspect, yeah, informatic fit. Maybe we can use also experimental with LLM, yeah. Also, LLM can make a new insight, maybe, yeah. Besides, they can also understand about the speech. Also, we can understand, LLM can understand the image, also the video image. They can also classification. This image is inside their tumor, maybe. Also can be used in classification in medical image, maybe. Yeah. So this is my suggestion. The future is we can use LLM to understand the classification. This is the good future. Yeah, the good future. Yeah.
Okay,
Not just deep learning. Deep learning is in our meditation is the classic one is
yeah.
bahasa Indonesia kuno, udah kuno.
Action. Okay.
Yes.
Okay, thank you. Any question for another participant from this room? No? And I will check to the Zoom room. There is no also question.
Okay.
Thank you, Prof. Penny. I think this is. Still have one
Still have one.
from the chairman of the conference.
Oh, for the chair.
Okay, maybe
Okay.
who's help for the for the microphone. This come from Mr. Gunawan, Prof. Feel free,
Thank you,
Prof.
Mr. Gunawan.
Yeah.
Yes.
Hello, Prof. Benny. Thank you very much for your interesting topic and presentation. Yeah, I'm interested with one of your slide that highlight about the attention to the aspect ratio. Could
Yes.
you explain more what happened when you experiment about the data set and then you find that actually the aspect ratio is, give
Yes. Yeah, means that
some performance decrease. Okay.
yeah, means that the aspect ratio is ratio about means that with the training one and then with the testing one. Yeah, this is aspect the ratio here. Also, we can use maybe 90% for training, and then testing is also 10% for testing. So we can also experience here maybe for training 70%, and then the testing is what is about 30%. But we have experience with this testing aspect ratio that the better is mostly is about 80% testing, and then 20% testing. This is the main the people in the world is know that this is a good ratio when we have when we running the experiment. Yeah. Also when we want to experimental make, so means that the data sets is 80% for testing. For training, and then 20% for training. This is mostly known. Yeah, this all over the world. Yeah, is about that. It's not about that. Yeah, this is mean our about the aspect ratio. Also, we have training 70, and then distortion is better. Distortion is bigger. Yeah. Also not good also when we have training with 90%, and then for training, and then 1% for testing is also make also distortion. Yeah. So the mainly experience that I have made is about 80%, and then 20% for test. I think this is mean about aspect ratio here. Thank you.
Okay, yeah. Thank you, Prof. Benny.
Thank you, Prof. Penny, about it. Any another question? Maybe I still open it. And still we have 5 minutes. Okay. Okay. On YouTube streaming, Prof. There is have question. Maybe one technician can read it for me about it. For Prof. Aben. I will check first, Prof.
Okay. 3 minutes again. We have to go to. We have another meeting with Dikti. I'm sorry.
Okay. I will check it from YouTube, Prof. Okay. This is Dita Mau Sali. There is any question from YouTube? Excuse me, can we ask question free via comment from? But there is no question.
That's
in here.
Alhamdulillah.
You
Yeah.
can text it.
Okay.
Mbak Dita, if you have
Yeah.
any question. But there is
Kemudian,
okay.
yeah, we have to go. I have to go.
Okay. Yes.
Yeah,
I
yeah.
think there is no question as a Indonesia.
Alhamdulillah. Yeah.
Okay. Thank you, Prof. Aben. I think
Yes.
this is what is valuable presentation for us, and
Amin,
maybe
amin,
will
amin,
be
amin,
enlarge
amin, amin.
our research about it, about
Yeah.
deep learning, or about prediction in tumor or something. And because of this, I want to express my gratitude, Prof. Aben, for sharing, and also want to thanks all of
Yes.
your active participant and also engagement. And maybe, yes? Oh, okay, Prof. Oh, this is the participant have one question.
Oh, one
Prof,
question.
that is okay, Prof. Maybe okay. I will check. I will check everything because we have this is Prof. We have a platform that's on site and Zoom, and also
Yes, from YouTube, yeah.
with YouTube.
Okay.
This is question? That's from? Okay. Or maybe once can read it for me. I don't know. This from. Read it for me. Oh, oh my God.
Okay.
This, I think is in it. Okay, thank you. I think it's all
Okay.
from Aben, and
Thank you very much
this
because
is
I have even meeting,
for
yeah.
sharing to us, and see you on maybe our collaboration is
Yes.
about this research, and thank
Yes.
you. And I close for this session for the first keynote speaker. And thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Izin pamit Bapak Ibu. Assalamualaikum warahmatullahi wabarakatuh.
Yes, thank you, Prof. Aben. See you next.
See you. See you.
Okay,
Assalamualaikum.
Assalamualaikum warahmatullah. And I give back the session to the Master of Ceremony. Thank you.
All right, thank you, Ms. Enda, for moderating the previous session. After this, we will have a break time until 11 p.m., 11 a.m. So to everyone, you can have a break until 11 a.m. and you can be back at this room at 11 a.m. Thank you.
sampai jauh.
Right, now we are continuing to the next agenda, which is our second keynote speaker, Professor Valerio Basile, moderated by Endang Wahyu Pamungkas, PhD. To Mr. Endang Wahyu Pamungkas, we welcome you to the stage.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone, and I hope you are enjoying this conference so far. And it's my great pleasure to welcome you to this second keynote session at International Conference on Smart Computing, IoT, and Machine Learning, or SIML 20 and 24. So today we have the honor of hearing from a distinguished speaker who has made a significant contribution to the field of natural language processing and beyond. And here I want to greet Professor Valerio Basile. Buongiorno, Valerio.
Hi, Endang. Selamat pagi, everybody.
Selamat pagi, actually.
Sorry.
Okay. Before we go to the keynote speech, I want to introduce Professor Valerio Basile. So, Professor Valerio Basile is an assistant professor at the Computer Science Department of University of Turin, Italy. And he is a member of Content-Centered Computing Group and the Head Speech Monitoring Group. And Professor Valerio Basile research spans a wide array of area, including formal representation of meaning, linguistic annotation, natural language generation, common sense knowledge, semantic parsing, sentiment analysis, and hate speech detection. He also focuses on perspective and bias in supervised machine learning, covering the entire pipeline from the data creation to the system evaluation. Professor Valerio Basile currently is the principal investigator of Project Break Head Down. Maybe you can tell us more about this, which aims to understand toxic language in online communication. He is also one of the main proponents of the Perspectivist Data Manifesto, which advocates for acknowledging and addressing bias in data. And with such an impressive background, so we are very excited to hear his insight on today's speech with title Perspective in NLP, Mining, Modeling, and Evaluation. So please give a warm welcome to Professor Valerio Basile. So the stage is yours now.
Thank you very much, Endang, for this very kind introduction, and it's so nice to see you all. I would really like to be there with you. One day this will be real, but for now I will be in Italy, so greetings from Italy. Let me see if I can share my screen. That should be possible. All right, so now you should be able to see my screen. All right, so what do I want to talk about to you today for this keynote? The keyword is clearly perspectives, and this will be the focus of the next hour or so. I would like to show a quick outline. So as you can see from the outline of this keynote, it is not very structured. I would like to try and convince you of the validity of a new approach called the perspectivist approach in natural language processing, but you will see that it's something a little bit more general than that. And so I will give you a few examples based on my actual experience. As Endang said in the introduction, I did some work on what is called now the undesirable language, hate speech, offensive language, that kind of stuff. That will be the running example. But the actual contribution that I'm going to present is a methodological thing. And then I will try to explain to you all the aspects of this approach, and again, provide more examples, because I think that's the best way of getting the message across. I will try to stick to the time. If I run too late, just stop me at some point. All right, so let me try also for kind of autobiographical reasons to start from my own experience. So to give you some historical context by now, back a few years ago, say 2016, 2015, up to 2019, I was very much involved in the community of sentiment analysis in natural language processing, which spans very different kinds of phenomena, from the analysis of actual sentiment, positive, negative, the emotional content of natural language and its automatic analysis. Up to the following years, 2018, 2019, we had a few projects, and I mentioned one of them, which is currently running, Break Hate Down, at the University of Turin, focusing on the analysis of hate speech and all those phenomena in language that are offensive, aggressive, and undesirable in general, right? So how do we do NLP in modern times? As many of you probably are already aware of, is mostly, well, up to a couple of years ago at least, it is mostly machine learning and supervised machine learning, which means what we typically do is we train models, statistical models, machine learning models on data sets, right? So one very, very important activity that takes a lot of time and effort is to create this data. The data sets for sentiment analysis, hate speech, takes a lot of annotation, data collection, but especially manual annotation and then agreement, etc. And in order to annotate something, you need to know what you want to annotate. You need to provide definitions. So while working on hate speech, in particular, we organized that shared task that's pictured there, a SIML task in 2019 about multilingual hate speech detection. We had to create a data set, very big one, and we had to provide and give a definition of what is a hate speech. Now, I just put a screenshot here, right, of a search on the Google Scholar of definition of hate speech, right? And you find so many different definitions, and especially all the papers, everybody starts with hate speech is a very difficult problem to define, or the definition of hate speech is very difficult, and so on, variation of that. So, right, we get it. It is very difficult to define. So what does that mean in practice? Yeah, this is just a few examples of many different definitions of the same phenomena that you find in natural language. And the same applies to other phenomena like irony or emotions in natural language text. So what does that mean? It means that you get the agreement between the different annotators is typically very low. And we go through this phase called harmonization, where after we annotate, different people annotate the same data, then we found that everybody thinks differently, and then we go through extenuating discussions about who's right and who's wrong. But when it comes to stuff that is so subjective, so perception-based, like hateful content or offensiveness, can you really say that someone is right and someone is wrong? Or is it more a matter of the subjective perception, right? So noticing that we were starting to not find agreement even when discussing after disagreeing on an annotation, we started formalizing this problem, right? Now, there is a disagreement. Disagreement is something that in an annotated data set you can measure. You can look at the different labels given by different people, and there are several measures, numerical measures, like Krippendorf's alpha or Cohen's kappa or whatever. So that is a signal, right? But we want to see where this disagreement comes from. So a few reasons we already knew, like the task can be just difficult, or the guidelines can be ambiguous, so people make mistake in the annotation and they end up disagreeing. Or actually, there is a new, a more and more important source of disagreement, which is the subjectivity. Now, studying these problems like hate speech and annotating data, we found out that a lot of times, two different people annotating differently the same text, they are both right. They just have a different perception, but they have very good arguments for different labels, right? So the subjectivity of the problem is an important factor determining the disagreement in the observed level in a data set, right? So with all these observations made, I came up with a kind of a thesis or a strong statement, let's put it like that. That was about 4 years ago, 2020. That ended up being written in a manifesto, which is a bit unusual, I understand, but I felt like it was the best way of putting up this new thesis at the time. The manifesto is actually called the Perspectivist Data Manifesto. There's a link there if you want to look into it. The thesis is that the way we do traditionally data annotation for natural language processing does not work very well, is obsolete when you point your attention towards tasks that are very subjective, like sentiment analysis or hate speech detection, phenomena like that. So this is the main point, actually, that we should change our way of doing stuff. So how should we change that way? Now, let's see here to the left and to the right what we typically do or did, and what I propose to do. So in a no perspectivist approach, so in the traditional approach, just summarizing to the extreme, what we do is in NLP is we collect data, we collect annotation, so labels on the data from different people, and then we aggregate them all. Typically, we just do a majority voting or something like that, right? And then we use this aggregated data set to train models, to evaluate models, and so on. Now, in a perspectivist framework, the way we want to do it is we still collect data and we still collect the annotation the same way, but then we do not aggregate anymore the labels. We want to keep all the individual labels from the individual people because they are informative, right? And then we use this disaggregated data to train and evaluate. That way, you can bring all this extra knowledge that is in the disagreement of the people all the way through the NLP pipeline, all up to the evaluation, right? That's easy, right? That's what I thought initially. That was 4 years ago. Okay, it should be easy. It's not a very difficult thing to do. It is a straightforward proposal, indeed, but it's not easy at all to implement it. And in the rest of this talk, I will try to convince you of how we're trying to create new methods to implement this idea in practice, in reality. Let me give you a couple of words on why this might actually be important. Well, one of the effects of aggregating labels of different annotators is that if there is some opinion of a minority opinion, I don't know if you still see my screen, hopefully yes. If some opinion is held by a minority of people, if you aggregate all the labels, it gets lost. You don't see that anymore, right? So are left out, and then it might be important. So think about hate speech. If I have I don't know 10 people in a room, and even one of them is deeply offended or find a message hateful, I want to record that information. But if I aggregate all the labels by majority, I lose that information. That's important. And also because in many cases, natural language is about, it's an expression of human culture. So not everything can be easily put into boxes of black and white labels, very crisp labels. Okay. I have also to point out that I was obviously not the only one thinking about these kind of problems, and also not the first. But later on, while formalizing on this idea of a perspectivist approach, I started to find out other people and other works that have been presented that are very much related to this. And actually, you will see we kind of created a little network and community of people around that. And I won't go through all of them, but notably there was a seminal work by Laura Royo in 2015 that was predicating the 7 myths of crowdsourcing data. And the very first one is that there is no truth. There is no one single truth, which means that for some phenomena, like the subjective phenomena in language, you may expect that two diverging opinions are both right. There's no a single truth. There's no such thing as this message is objectively offensive. It might be offensive to someone and not to someone else. All right. Also, another terminological point, disagreement is one thing, and it is very much related to perspectives, but perspectives are something that emerge from disagreement. There might be disagreement in data without the effect of having different subjective perspectives. There might be disagreement for different reasons, as we saw, just as noise in the data. Not all disagreement comes from actual different personal perspectives. Okay. So, at the more practical level, right? So what does that mean in terms of creating methods and models for natural language processing? I am still thinking, but this change over time, that there are like 3 or 4 main activities that all can be influenced by a perspectivist approach. One is that of mining, extracting different perspectives from the data. One is that of actually modeling, so creating models that account for different points of view of different groups of people, and then evaluating under this new framework, and finally using this new extra information from the disagreement to also trying to explain the predictions of models. I'll try to give you a few examples, especially of modeling, but also mining and evaluation, right? Good, so enough chit chat. I'm going to show straight a few examples from now on from the very recent literature from my research group. All right, you still with me? I hope so. I don't see you, but I take it is. All right. So first example, let's go back again a few years. We are in 2019, 2020. A PhD student in our group, Sohail Akhtar, was working on hate speech for his PhD, and he was noticing that he wanted to give the opinion of the victims of hate speech while annotating a dataset more important. So his thesis was, if the dataset talks about hate speech against, in that case, it was Muslim immigrants in the UK, I want the opinion of those people to matter more. Right, so their label should weigh more, right? So we took this idea and we tried to actually generalize it a little bit. And he had data already when I started supervising his PhD. He had this data set of about 1,000 tweets annotated by 6 people. 3 of them, this is crucial, 3 of these people were actual Muslim immigrants in the UK, speaking English, and other 3 people were from, we call that the control group. They come from a Western background. There were 3 PhD students, I think. Maybe Endang was one of those, I think, or there were people in that cohort, I think. So what happened, what we measured in this annotated data set is we wanted to measure, all right, so how is this disagreement made of, actually? So these people are all disagreeing to some extent, but how? In what exact way? So we divided the annotation into 2 groups of people. We came up with an index with a just very simple way of calculating whether the people in one group were agreeing and the people in the other group were also agreeing, but the 2 groups were disagreeing with each other. So this is a numerical measure, we call it the polarization index, that gives you a high number in that case. So if the annotations are polarized, you have a group of people with one opinion, another group of people with the opposite opinion, and but internally there is coherence. So we calculated that on this data set, and here you also see a matrix of pairwise disagreement, and the signal was very, very strong. So the 3 Muslim immigrants were agreeing with each other a lot. And the other 3 people were also agreeing with each other a lot, but they were not thinking the same, actually, on the same data. So this was very interesting first signal. So we started experimenting with this idea. So we thought, let's try and use this index to give more importance in the training of a model to the data where there is a low polarization and the other way around. So let's try to manipulate the training set based on this kind of refined measure of agreement. So we did some experiments. I'll go quick on this. I'll just, I will give you all the references to check the numbers afterwards. But the important message is that we noticed that an improvement, which means that this was the first time that we noticed that if you take these different perspectives of different groups of people into account, your models are more accurate, right? They have more knowledge, and therefore they provide you with more informative output, right? We also found out at this time that you can use this kind of information. So if you do not aggregate the data, you have a lot more information to just explore the data, to find out, to make emerge the interesting instances, the ones that make people disagree in a more polarizing way. So in the case of hate speech against immigrants, we found a lot of jokes, for instance, to be perceived very differently by different groups, social groups of people. And some topics in particular were really polarizing the opinions, right? This is something that you cannot do if you just aggregate all the data sets and you just calculate an agreement measure on a global scale on a data set, right? So at that point, we were convinced that this may work. It was promising, so let's do one step further. Still, this was also work with Sohail. So we thought, all right, so far, we have the data set, we aggregate, we create one model. But if we know now that we have two different, distinct groups of people annotating the same data set, why don't we model both groups? So why don't we try and create two different models? This is exactly what we did in the follow-up experiments. I think there's a schema here. So what happened here is that, I hope you see my pointer. We have the standard data annotation. As I saw, this is the Brexit data. But then we split the training set longitudinally. So we create two different data sets where the texts are the same, but the labels come from different groups of people. So we have two slightly different training sets, and we use that to create two different models. At this time, by models, we mean, I think it's fine-tuning a birth-based model, something like that. It was 2020, roughly. So the two different models are supposed to encode the perspective of the two different social groups. And we also, for this experiment, create something we call the inclusive classifier. Inclusive actually in the inclusive or sense, meaning that here the task is hate speech detection, and the inclusive ensemble of the two classifiers means that simply if one of the two classifiers outputs a yes label, so a positive label, so this is hate speech, even if just one of the two says that, then the inclusive ensemble will say that, will say inclusively yes. So we will expect a higher recall from this classifier. And then we just test all of these outputs on the same test sets. And this is exactly what we got. We actually had three different data sets for this on slightly related undesirable language phenomena. It's sexism, racism, and homophobia data sets in English and in Italian. What we notice is that almost always, if you take the perspective of the users, of the annotators into account, you get a better classifier. That's almost across the board. We notice that if you take all of them in some kind of ensembling way, even if it's that simple, you always get a better result, even though it is on an aggregated test set, but we will get to this detail later. We also noticed something that we were not expecting, that at least in this data set, the model trained on one of the two groups, you guess which one, is consistently more accurate than the other model. That means that there is a kind of asymmetry. So it's more something like some group of people is a bit more right on that particular language phenomena than the other group. And you might guess which one. In this case, this confirmed the original hypothesis by Sohail Akhtar, which means that victims of hate speech in that case matter more. Their opinion is more coherent, more accurate, right? Or at least on this phenomenon. So at this point, we were convinced. So we went looking for the single very important scientific item that we all need to conduct good research, which is, it is sad to say, money. And we got some money. Luckily, we got some funding from a research office of Amazon Science, which is located actually here in Turin, where we are. So it's a branch of Amazon, the research venue of Amazon. We got in contact. We established a collaboration together that was already more than 2-3 years ago about. So we created this joint group and we started working on this, developing more and more of these methods. They were interested in that, of course, but in terms of phenomena in language, they are more interested in irony, and you might understand why. They are developing conversational agents, Alexa in particular, and if you ever used something like that, you know that it doesn't really get your jokes. Their jokes doesn't really make you laugh, but especially even if it has some pre-coded, hard-coded sense of humor, it is not really perspectivist. I mean, it will be the same kind of humor for everybody. And there is not many things in the world that are subjective as humor and irony, in the perception of irony, right? Something that makes me laugh will probably not make you laugh, and the other way around, right? So I created this very nice group of people. Now, some of them are going elsewhere, some other new people are coming, but this was the composition at the time. And we started crunching data. This is what we do best, right? We created a new data set, this time a much larger one, and focused on irony. So we created a data set called EPIC. This was presented at ACL last year, 2023. The English Perspectivist Irony Corpus. Now, just to give you a spoiler, we have a multilingual version, which is called Multipico. It just got accepted at the next ACL, which will be in Bangkok in a couple of months. Right? And if you are there, come talk to me because I will be there. But anyway, for EPIC, we focus to start with only on the English part. We collected some data from Reddit and Twitter, so social media data in English. The data is very short conversations. I will give you an example. So there is a context and a reply to some post, and that is the instance. We asked many annotators using a crowdsourcing platform to annotate the ironic content of the reply. I have an example here. Yeah. So this is what the annotator saw. So there's a message, there is a reply, and there's one very simple binary question to the annotator, which is the reply ironic? Yes or no? Right. Just a few more information on the data set. Crucially, we selected both the data and the annotators from different regions speaking English. So we have people and also data from United Kingdom, United States, Ireland, Australia, and India. Right? So we wanted different varieties of English, but also different perspectives of the annotators, hypothesizing that coming from different regions of the world, they might have different cultural backgrounds and therefore different perception of irony, different sense of humor. This is what we really aim to capture in this data set. We also got, just from the platform, some extra information about the people, which is mostly gender and age. And since we got that information, we decided also to use it to model our annotators and their diversity. At the end, each of the annotator annotated about 200 texts. So each of the texts, there are 3,000 in total in the dataset, are annotated by an average of 5 people. The dataset is online. You can just download and play with it. And then it took some time and some money to create it, and therefore we got straight into it. We started analyzing it. We published some preliminary analysis work on how this dataset is composed in terms of annotation. We found that different groups of people, they all disagree, even internally to a certain extent, but in a very different way. So the perception of irony from different age groups, for instance, or from different regional groups are very different. This was kind of expected, of course. Then we started trying modeling and create different models, a bit like we did with the previous experiment, but on a larger scale, to try and model all these different perspectives of people in actual computational models. And here again, we are talking about fine-tuning encoder-based language models. So we were still pre-LLMs slightly at this point in time. So this is what we did. We had all these different social groups in our data set. You see there's the different generations, Generation X, Generation Y people. This is age, right, difference. There, we have annotators from different regions, Ireland, India, etc., male, female. So for all of these social groups, we cut only the annotations coming from people of that specific group, and we create a model only based on that. We train a classifier based on that. So we end up with all these different classifiers, right? And we can actually test them on the same kind of divided test sets, and we get a lot of numbers. And then we looked into all these numbers, and we didn't know what to do because you cannot really compare these numbers, right? They are tested on different test sets, but you cannot also test all these models on the same test sets because it doesn't make much sense. Of course, a perspective-aware classifier, so a classifier meant to encode one single perspective, will have a lower performance on a traditional aggregate dataset. But that, of course it is like that, but it's not because the classifier is not good. It's because the test set is modeling like the opinion of the majority. So by definition, you will get a lower performance, but that's not the point. So this is where we got stuck. So what do we do with this? Nevertheless, this table is in a paper that was accepted at the first round at the major conference, which means that also the reviewers understood that this was not the actual point. But we also noticed something else while not looking at the actual classification performance, but looking at the other column, the so-called confidence. Now, most of you may know already, but let me just quickly repeat. When you train a supervised classifier, then the output is typically a distribution over labels that then you softmax and you get one exact label. But there are also different measures and different ways of measuring how confident is the classifier. Even just the difference between the pre-softmax distribution and the actual label you get in the end can give you a simple measure of confidence. There are better measures of that. So we're looking at the confidence of all these perspective-aware classifiers, and we were noticing that they were quite high. They were much higher than the original classifier trained on aggregated data. Oh, sorry, there's music. Give me just 1 second. Sorry. Sorry, my wife left her phone around here. It is 6 a.m. in Italy. Anyway, so the confidence was key. And this is the information that we decided to leverage, actually. We noticed that the classifiers trained on single individual perspectives were more confident. So this is a very simple depiction of the idea we had. So if you ask 8 or a number of different classifiers for an answer on a subject, a phenomena like irony, you will get many different answers. So that's depicted in the different colors. So some of the classifiers will say yes, some will say no, but also they will say that with different levels of confidence, right? And you may end up in a situation where you have a minority of the classifiers telling you the red one, whichever that is. But they are more confident. They are more confident in that. They are more sure of their answer. So we had this idea of ensembling all the output from all the different perspectives encoded by the different classifiers and weighting their contribution by the confidence of the classifier. So we created an ensemble of different classifiers, but this time was more refined than the first experiment because it was based on how confident the individual models were. So we created all of this, trained on the data from EPIC, so irony again, and we experimented this time extensively using different models, etc., different experimental settings. And what we found is that if you do it like that, so if you take into account, again, all the different perspectives of all the different people in your data, and somehow you account for that in your final classification, you get a much better performance. And that's because you have way more information in your data and therefore in your model. And we found that this works in datasets and cross datasets, so in domain and cross domain. We trained on EPIC, we tested on some aggregated dataset from an older SIML task. It also works on other phenomena. We tested that on hate speech, again, in domain and cross domain. This was published last year at the EMNLP, mainly work by Silvia Casola, postdoc of our group. Right. Okay, so this is enough for now about modeling. I talked more than half an hour. I'll tell you about some other aspects of perspectives, but this is still going on. Of course, we're doing more models, especially with LLMs. So the other interesting thing you can do when you have disaggregated, so non-aggregated data sets, is sometimes you have the information about who are your annotators. That is the case of Brexit data. That's the case of this EPIC dataset. By construction, we asked the people who they were also when they were annotating. But sometimes you may not know. Maybe you have data coming out of a crowdsourcing platform without any information about the people, or you may not want to know because for privacy reasons, for instance, right? So one other interesting thing you can try and do with disaggregated data is to try and mine the perspective. So you know that different people annotated a data set, but who are they? Right? And even if you have that information, it has been noticed that in this very nice paper called The Ecological Fallacy, that there might not be a good alignment between the declared groups of people, like region of origin, nationality, age, this kind of information, and the difference in the annotations. So there might be other factors involving the disagreement in irony, for instance, right? I am hearing something. No? Shall I go on?
No.
No, okay. Shall I go on? It was just noise. All right. So we did some work. We tried again to do some work in this direction. So this is what the task that we call mining the perspective. So again, we go back a little bit in time. I'll show you just some preliminary work first. We had this idea of extracting information about the people, the annotators, from the data already back in 2021. We had a postdoc in our group called Michael Fell there, and he worked on the same Brexit dataset. So the same dataset I talked to you about. So 6 people, 3 from one group, 3 from the other group. Right? What he did is he took the data in different direction. He took all the annotations given by each of these 6 people, and that is a vector based, basically, right? It's a sparse vector sometimes, or dense depending on the data set. And he manipulated that vector somehow, so he got vector representations of the annotators, right? And then he just started to cluster them and looking into what this clustering meant and the correlation between these different clusters and engrams, so words or sequences of words in the text that were the most sensitive to eliciting different annotations, or so polarized annotation. So he did this little engram studies, and we found some interesting results in there. This was just a qualitative analysis. But we found that in different data sets, for each of the actual phenomenon encoded in the dataset, so Brexit dataset is about hate speech, this datasets about sexism and racism, homophobia, etc. But what we found is that the actual topics that elicit the most the polarization are always very specific. And that's one thing. And the other thing is, again, the same asymmetry that we noticed in the previous experiments, that for one group of annotators, there was always more, let's say, more polarization than for the other group of annotators. It's kind of like there's always a vocal group, so someone that's really polarizing their opinion on some instances of text, and the other group is more sparsely distributed in terms of their annotation. So again, we started experimenting more and more with this now that we have data from EPIC and the multilingual version that we were creating just now. So we brought this idea of clustering the annotators more and more. I think we can skip this. So at this point, we had a PhD student in the group, which is Sodamarem Lo, depicted there. And most of her PhD is actually on this kind of topic. So getting good numeric representations of the annotators in a disaggregated dataset. And then by clustering this representation, you're actually clustering people. And then you try to give an explanation of why and how people cluster together in terms of their opinions, the opinions they express by providing the annotation, right? One of the things she did with success is that, if you remember the ensemble classifier, the confidence-based ensemble that I just presented before, the one that worked all across the board, we replicated the same experiment, but instead of dividing the data of EPIC by regional origin, by age, by group, we took a division of the annotator, a grouping of the annotators, just based on clustering, so without knowing anything explicit about them, only using the information about their annotation they provided. So if you create these groups bottom up, it actually, not only it works, but in many cases it works even better. This is a confirmation also, this ecological fallacy hypothesis, that yes, age plays a role, and gender may play a role, and the origin, nationality plays a role in the different perception of irony. But there might be even other better divisions, better ways of splitting people that polarize their opinion even more. So there are other factors involved in our perception of such a subjective phenomena. And with disaggregated data set, if you do not aggregate your labels, you may find that information in the data with automatic methods, such as clustering.
Valerio?
Okay. Yep.
Could you finish it in maybe 5 minutes?
Yes, I will.
Grazie.
Okay. All right, so we have another work which is coming up. I'm going to actually go to present this at NACL, which is next week, a couple of weeks in Mexico, which builds on this. This is the work from Nigar Mokbarian, mostly, who is a PhD student at USC, California. He came visiting our group last year, which takes this idea further by actually trying to learn the representation of the annotators instead of just taking this representation and manipulating, let's say, statically, by learning this representation during the same process as learning the representations of the text. And this is going to be presented soon. And yeah, so I'm coming to the end of the talk. I presented you the work done in modeling perspectives and mining perspectives. I will just say a few words, but you will say why on the other aspects. So the evaluation of under a perspectivist approach is still kind of an open problem. It was noticed already at the beginning. In the very first position paper I wrote about this, it was actually about evaluation. Because what is the problem here? The problem is that, yes, we learn and we are learning how to train models on disaggregated data sets. But if we test these models on aggregated data sets, aggregated test sets, we are still missing the point, right? So we are not really evaluating the capacity of the models of encoding different perspectives. But we still do not have very good ways and measures to also test in a perspectivist way. We had some tries. There is a shared task in SIML which tries to evaluate distributions of labels against distributions of labels. So it's one step forward. There have been other proposals by treating perspectivist classification as multitask learning. So you can predict one label per each annotator, and then you treat them as different tasks. But that also has some limitations. It doesn't work with very sparse data sets, for instance, only on very dense data sets where everybody annotated everything. So we're still not there. There is a benchmark we're working on, but this is for next year, maybe. I'll talk to you about that in the future. I'll skip that. Very quick word in the explainability part. There is only very preliminary work. I just show you one because this comes from very interesting workshop. There is people that used the Brexit data and a very refined, explainable, interpretable, syntax-based classifier to show that different people disagree on the same data about hate speech in this case by looking at different parts of the text. So this was very interesting, but rather preliminary work in terms of how you can leverage the disagreement in the data to explain the difference of perspectives. So why different groups of people actually disagree with each other. So this is the original slide, and this is how the status of affair at the moment. So mining perspectives and modeling perspectives, etc. I hope I convince you we have something going on. It's been a few years now. There have been many proposals. I just shown a few of them, the one coming from our own group, but there's other things going on from other parts of the world. The evaluation part, how to evaluate perspectivist models, we are getting there, I think. There's still no definitive answer. There's no one unified framework yet. The explanation part, I think it's very, very interesting. And now with all the work on LLMs, generative models may really help leveraging the disagreement to provide explanations, but we are still at a very preliminary stage, which is good, means more work for us. And that is it. Let me just mention that there is a lot going on at the moment. There is a workshop called NL Perspectives. We just had the third edition a few weeks ago, actually here in Turin. Maybe some of you were here, the NREC calling a joint conference. There's mailing list, shared task I already mentioned, and other things going on. And with that, I think I can stop here and I could take a question. I will not even try to pronounce, but thank you very much.
Okay. Please give applause to Professor Valerio Basile for the insightful talk. Okay, I think it's very insightful, and maybe it's still we still have some time maybe for two questions if here in Zoom or maybe on-site participant if there is a question. Okay.
Okay, thank you. I will introduce myself. My name is Deden Ardiansyah from Diponegoro University. I have question to Valerio Basile about I interest about of Evalita.it, Valerio. I think this question, how to clustering modeling NLP in variety language for Evalita. I think in Italy, in Evalita have approach to consistent manner, and how to you make the combine the different language, the clustering for the NLP. I think it's my question.
Okay, no, thank you very much for the question. I'm surprised positively that you know about Evalita, so let me spend a couple of words on that. Evalita is a running evaluation campaign, kind of like SIML, but specific for the Italian language. It has been going on for, it's almost 20 years, I think. The first edition was in 2007. Every 2 or 3 years, the Italian community organizes these evaluation campaigns. There are many tasks in that. Actually, what is going on right now is very important, interesting, new, and I think also related to the talk that I just gave. The last edition of Evalita was in 2023, so last year. And even in that case, and that is the same for all the editions of Evalita so far, it is all, let's say, pre-perspectivist. So all the tasks are all very interesting and organized by colleagues from all around Italy and the world, but there is no perspectivist approach yet. It is too new, probably, to propose something like that to the community. I think that the only shared task that is proposing disaggregated data sets and therefore perspectivist approach is this one, is the SIML task. Maybe I can, I had a better, well, it's this one, yeah, the SIML task, right? The learning with disagreement. Now, since the NLP community is moving very fast, and there has been a couple of years ago this advent of large language models, which I did not talk about. I know that I do not talk about. I have a hidden slide on that if you're interested in that. The Italian Association of Computational Linguistics decided to organize a special edition, which is not called Evalita, it is called Calamita, but it's very similar thing. It's the same idea, but turned around a little bit. So what will happen this year with this Calamita evaluation campaign is different people, organizers, will provide data and examples of prompts, and then all the evaluation will be run by one single organizing committee. This is different from the traditional Evalita way of working, right? Now, in the context of Calamita, it was myself and with Silvia, we proposed EPIC. Well, the Italian version of EPIC is called Multipico, but the same kind of data. So a disaggregated data set of irony. We proposed that to the community in a disaggregated way, hoping that someone can make use of the disaggregated data set and create some perspective-aware classifier about that. The data will be provided fully. That means that it also includes the metadata about the users. Then it will be the task of whoever is running the model how to leverage the information about the annotators to make better predictions. And that may include clustering. I think that was part of your question. Or it may include some procedure like the other work that I briefly showed, which is this one, which is going to be presented soon, where there is clustering of the annotators, but it's more implicit. What happens in this kind of new models is that you have information about the text, you have information about the annotators or users, as you want to call them, but they go through the same machine learning architecture, and which learns representations for the text and for the annotators at the same time. So in a way, they will be clustered by learning. There will not be an explicit clustering steps. I don't know if this answers your questions a little bit, or you have follow-ups?
The clustering from different language in Evalita. I think this presentation very explain about that. Learning another representation. I need here. This is
Yeah, I hope you may
modeling
come
or
to Mexico.
learning another representation. This is your modeling.
Yes, yes, this was work mainly done by Nigar Mokberian, who is concluding her PhD at University of Southern California, with me as well. I will actually be at the conference presenting that in 2 weeks. In a couple of weeks, I will fly to, this is Mexico City. NACL is the Northern American chapter of the ACL, of the Association for Computational Linguistics. And I will be presenting this paper. And there is already some work, like some follow-up work planned, where we want to bring back the idea of clustering these representations of annotators, but still during the learning process. And the way you can do that, you can leverage some special or customized loss functions, something like triplet loss or variations of that, which means that it's loss functions that try to divide or set apart in the space representations of annotators that are more different, and to group representations of annotators that provided more similar annotators. So in a way, it's a push toward clustering. I'm not sure if we should call that actually clustering, because clustering is what we did with the previous work with Marem law, which means you do it statically before going through a learning process. But the effect will be the same. This is what we expect. So we want to learn representations of the annotators, which somehow identify some groups, which we hypothesize are either actual socio-demographic groups or just groups of people that for any reason have a different perception on that specific phenomena of your dataset, or irony or hate in our case.
Okay, thank you.
Okay, thank you very much. Maybe one last quick question, if there is still. Okay, maybe from me, one quick question, Valerio. I missed to discuss with you actually. So
Me too.
As you know that annotating data, for example, for head speech is very subjective, and as you said before that the data from annotator is very important. I want to ask about your opinion or recommendation. If there is a data set, for example, let's take example for sentiment analysis or head speech, and the data set has a very low disagreement, and they also didn't share the annotation data. What should we do based on your opinion?
Yeah. Okay. So I've been through this situation actually. So this happened to me. Now, these ideas started to circulate a few years ago in a very organic way, meaning that there was this manifesto, then people start writing to me and then to each other. Then we created a mailing list, but it's a little community, not very much organized top down. And I started looking at popular data sets. The Davidson one was an example. Yeah, it was one of the data sets mentioned here, for example. It is still a very popular data set of hate speech, but it was published in an aggregated way. All the data sets, almost every data set, was and still is provided aggregated, so with one single gold label, one single ground truth label. So what you do in that case is very human. You ask people. So, for instance, for Davidson is the name of the author, is Thomas Davidson. I just asked him, and he was very quick to reply with the original output from the crowdsourcing platform, so the disaggregated data I needed, and that was amazing. So sometimes you can ask, and people still have the data. Unfortunately, that is not always the case. There is another very, very popular data set I will not name because there is no ill intention in that. But I had to chase the authors for months and months. Also, they were moving around the world, asking if they still had the original annotations before aggregating them. And at the end, they had to confess that they lost the original dataset and they only retained the aggregated dataset. Now, this is very common, and I have to be honest, it happened to me as well. So if you ask me, the original disaggregated, so before aggregating the labels, version of some datasets even I produced maybe 10 years ago, I may not be able to find all of them. I see that this is changing. I see data sets that are being published in a disaggregated way, so with all the complete annotations right now, even if that's not the main point of the data set. So even for phenomena where you will not expect a lot of relevance of a perspectivist approach, so like in syntax or image data sets. I hear voices.
Please continue, sorry.
Okay. Yeah, but anyway, that is the point. So there is a new sensitivity in the community. I'm very happy to see that. The only thing we can do is to continue to keep the attention on the importance of distributing data sets in the more complete way possible. So with all the labels, even if you think they're not important, they may be important in the future for someone else. So that is the only thing you can do. Otherwise, you have the initial part of your question was about the agreement. If you have a data set and you know that there is a low agreement on that, and you have no way of explaining why, because you do not have the original labels, then I think it is useless. It is not very, you can train models on that data set, but as we say in machine learning, garbage in, garbage out, that will be garbage because it is not informative data. Although if you have disaggregated data sets, even if you have an inter-annotator agreement that is very low, that is not a problem anymore because you have ways of, you have all the information that allows you to understand and model why the overall agreement is low. So I hope this answers your questions.
Yes, thank you very much. Yes, that's answer my question. Okay, yeah, I think it's already 60 minutes. Yeah, thank you very much again for Professor Valerio Basile. Maybe applause once again.
Thank you, and again, thank you everybody. It's been an honor for me. I hope to visit one day.
Yeah, I hope so. Yeah, I hope to meet you very soon. I hope. Okay, thank you. So by the end of this second keynote speaker, I want to give again to the Master of Ceremony.
All right, thank you, Mr. Endang, for moderating the previous session. Now, ladies and gentlemen, after this we will have a break time for Salat and as well as lunch before we carry on to our third keynote speaker. So to all of our participants, if you want to pray, you can go to the third floor using the left or right lift, and please be back at this room on time at 1 p.m. Thank you.
Like California. Burning in your eyes. You look at me, and babe, I wanna catch on fire. It's buried in my soul, like California. When you let her go, only know you for now when you're feeling low. Only hate the road when you're missing home. Only know you love her when you let her go. And you let her go. Staring at the bottom of your glass, hoping one day you'll make a dream last. But dreams come slow and they go so fast. You see her when you close your eyes, and maybe one day you'll understand why everything you touch surely dies. Well, you only need the light when it's burning low. Only miss the sun when it starts to snow. Only know you love her when you let her go. Only know you for now when you're feeling low. Only hate the road when you're missing home. Only know you love her when you let her go. Staring at the ceiling in the dark, same old empty feeling in your heart. 'Cause love comes slow and it goes so fast. Well, you see it when you fall asleep, but never to touch and never to keep. 'Cause you loved her too much and you dive too deep. Well, you only need the light when it's burning low. Only miss 'Cause you only need the light when it's burning low. Only miss the sun when it starts to snow. Only know you love her when you let her go. Only know you've been high when you're feeling low. Only hate the road when you're missing home. Only know you love her when you let her go. Well, you only need the light when it's burning low. Only miss the sun when it starts to snow. Only know you love her when you let her go.
Can I call you baby? Can you be my friend? Can you be my lover up until the very end? Let me show you love, oh don't pretend. Stay by my side even when the world is giving in. Oh don't you worry, I'll be there whenever you want me. I need somebody who could love me at my worst. No, I'm not perfect, but I hope you see my worth. 'Cause it's only you, nobody knew I put you first. And for you, girl, I swear I do the worst. If you stay forever, let me hold your hand. I can feel those places in your heart no one else can. Let me show you love, oh don't pretend. I'll be right here, baby, you know I'll sink or swim. Oh don't you worry, I'll be there whenever you want me. I need somebody who could love me at my worst. No, I'm not perfect, but I hope you see my worth. 'Cause it's only you, nobody knew I put you first. And for you, girl, I swear I do the worst. I need somebody who could love me at my worst. No, I'm not perfect, but I hope you see my worth. 'Cause it's only you, nobody knew I put you first. And for you, girl, I swear I do the worst.
That Arizona sky burning in your eyes. You look at me and babe, I wanna catch on fire. It's buried in my soul like California gold. You found the light in me that I couldn't find. So when I'm all choked up but I can't find the words, every time we say goodbye, baby, it hurts. When the sun goes down and the band won't play, I'll always remember us this way. Lovers in the night, poets trying to write. We don't know how to rhyme, but damn, we tried. But all I really know, you're where I wanna go. The part of me that's you will never die. So when I'm all choked up and I can't find the words, every time we say goodbye,
when the whole world fades, I'll always remember us this way.
Not trying to be indie, not trying to be cool, just trying to be in this. Tell me, are you too? Can you feel where the wind is? Can you feel it through all of the windows inside this room? 'Cause I wanna touch you, baby, and I wanna feel you too. I wanna see the sunrise on your sins, just me and you. Light it on the run. Let's make love tonight. Make it up, fall in love, try. Baby, I'm with you, but you'll never be alone. I'll be with you from dusk till dawn. I'll be with you from dusk till dawn. Maybe I'm right here. I'll hold you when things go wrong. I'll be with you from dusk till dawn. I'll be with you from dusk till dawn. Baby, I'm right here. We were shot like a jacket, so do your zip. We would roll down the rapids to find a wave that fits. Can you feel where the wind is? Can you feel it through all of the windows inside this room? 'Cause I wanna touch you, baby, and I wanna feel you too. I wanna see the sunrise on your sins, just me and you. Light it on the run. Let's make love tonight. Make it up, fall in love, try. Baby, I'm with you, but you'll never be alone. I'll be with you from dusk till dawn. I'll be with you from dusk till dawn. Maybe I'm right here. I'll hold you when things go wrong. I'll be with you from dusk till dawn. I'll be with you from dusk till dawn. Baby, I'm right here. Gotta give love to your body. It's only you that can stop it. Gotta give love to your body. It's only you that can stop it. Gotta give love to your body. It's only you that can stop it. Gotta give love to your body. Gotta give love to your body. But you'll never be alone. I'll be with you from dusk till dawn. I'll be with you from dusk till dawn. Baby, I'm right here. I'll hold you when things go wrong. I'll be with you from dusk till dawn. I'll be with you from dusk till dawn. Baby, I'm right here. I'm with you from dusk till dawn. Baby, I'm right here. I saw you dancing in a crowded room. You look so happy when I'm not with you. But then you saw me, caught you by surprise. A single teardrop falling from your eye. I don't know why I run away. I'll make you cry when I run away. Take me back, 'cause I wanna stay. Save your tears for another. Save your tears for another day. Save your tears for another day.
months under a Pisces moon. I kept my distance cause I know that you don't like when I save your tears for another day.
Baby, take my hand. I want you to be my husband, 'cause you're my Iron Man, and I love you 3000. Baby, take a chance, 'cause I want this to be something straight out of a Hollywood movie. I see you standing there in your Hulk outerwear, and all I can think is where is the ring? 'Cause I know you wanna ask, scared the moment will pass. I can see it in your eyes, just take me by surprise. And all my friends, they tell me they see you're planning to get on one knee, but I want it to be out of the blue, so make sure I have no clue when you ask. Baby, take my hand. I want you to be my husband, 'cause you're my Iron Man, and I love you 3000. Baby, take a chance, 'cause I want this to be something straight out of a Hollywood movie. Now we're having dinner, and baby, you're my winner. I see the way you smile, you think about the out. You reach in your pocket, emotions unlocking, and before you could ask, I answered too fast. And all my friends, they tell me they see you're planning to get on one knee. So now I can't stop thinking about you. I figured out all the clues, so now I ask. Baby, take my hand. I want you to be my husband, 'cause you're my Iron Man, and I love you 3000. Baby, take a chance, 'cause I want this to be something straight out of a Hollywood movie. Ba-da-ba-dum-dum. No spoilers, please. Ba-da-ba-dum-dum. No spoilers, please. Baby, take my hand. I want you to be my husband, 'cause you're my Iron Man, and I love you 3000. Baby, take a chance, 'cause I want this to be something straight out of a Hollywood movie, baby. No spoilers, please. Da-da-ba-dum-dum. No spoilers, please. time we say goodbye, baby, it hurts. When the sun goes down and the band won't play, I'll always remember us this way. Lovers in the night, poets trying to write. We don't know how to rhyme, but damn, we try. But all I really know, you're where I wanna go. The part of me that's you will never die. So when I'm all choked up and I can't find the words, every time we say goodbye, baby, it hurts. When the sun goes down and the band won't play, I'll always remember us this way. Oh yeah, I don't wanna be just a memory, baby, yeah. Ooh, so when I'm all choked up and I can't find the words, every time we say goodbye, baby, it hurts. When the sun goes down and the band won't play, I'll always remember us this way. When you look at me and the whole world fades, I'll always remember us this way.
Collaboration is key for team success.
I'm going under, and this time I fear there's no one to save me. This all or nothing really got a way of driving me crazy. I need somebody to hear, somebody to know, somebody to have, somebody to hold. It's easy to say, but it's never the same. I guess I kinda like the way you're numbed on a pain. Now the day bleeds into nightfall, and you're not here to get me through it all. I let my guard down, and then you pull the rug. I was getting kinda used to being someone you loved. I'm going under, and this time I fear there's no one to turn to. This all or nothing way of loving got me sleeping without you. Now I need somebody to know, somebody to heal, somebody to have, just to know how it feels. It's easy to say, but it's never the same. I guess I kinda like the way you help me escape. Now the day bleeds into nightfall, and you're not here to get me through it all. I let my guard down, and then you pull the rug. I was getting kinda used to being someone you loved, and I tend to close my eyes when it hurts. and then you pulled the rug. I was getting kinda used to being someone you love. Now the day bleeds into nightfall, and you're not here to get me through it all. I let my guard down, and then you pulled the rug. I was getting kinda used to being someone you loved. Can I call you baby? Can you be my friend? Can you be my lover up until the very end? Let me show you love, oh don't pretend. Stay by my side even when the world is giving in. Oh don't you worry, I'll be there whenever you want me. I need somebody who could love me at my worst. No, I'm not perfect, but I hope you see my worth. 'Cause it's only you, nobody knew I put you first. And for you, girl, I swear I do the worst. If you stay forever, let me hold your hand. I can feel those places in your heart no one else can. Let me show you love, oh don't pretend. I'll be right here, baby, you know I'll sink or swim. Oh don't you worry, I'll be there whenever you want me. I need somebody who could love me at my worst. No, I'm not perfect, but I hope you see my worth. 'Cause it's only you, nobody knew I put you first. And for you, girl, I swear I do the worst. I need somebody who could love me at my worst. No, I'm not perfect, but I hope you see my worth. 'Cause it's only you, nobody knew I put you first. And for you, girl, I swear I do the worst.
Georgia, wrap me up in all your I want ya in my arms, so let me hold ya. I'll never let you go again like I did. Oh, I used to say I would never fall
so let me spell it out. A, B, C, D, E, F, you and your mom and your sister and your job and your broke ass car and the shit you call art. Fuck you and your friends that I'll never see again. Everybody but your dog, you can all fuck off. Na 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 na. A, B, C, D, E, F, off. Na 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 na. A, B, C, D, E, F, you and your mom and your sister and your job and your broke ass car and the shit you call art. Fuck you and your friends that I'll never see again. Everybody but your dog, you can all fuck off. Heart beats fast, colors and promises. How to be brave? How can I love when I'm afraid to fall? But watching you stand alone, all of my doubt suddenly goes away somehow. One step closer. I have died every day waiting for you. Darling, don't be afraid. I have loved you for 1,000 years. I'll love you for 1,000 more. Time stands still, beauty in all she is. I will be brave, I will not let anything take away what's standing in front of me. Every breath, every hour has come to this. One step closer. I have died every day waiting for you. Darling, don't be afraid. I have loved you for 1,000 years. I love you for 1,000 more. And all along I believed I would find you. Time has brought your heart to me. I have loved you for 1,000 years. I love you for 1,000 more.
but not much coming out your mouth. Can't you tell that I want you? I say yeah. I would want myself. Baby, please believe me. I'll put you through hell. Just know me, yeah, yeah. So sure of yourself. Baby, don't get greedy. That shit want it well. Ooh, and well. I see you eyeing me down, but you'll never know much past my name or how I'm running this room around, and that I'm still half your age. Yeah, you looking at me like I'm some sweet escape. Obvious that you want me, but I said I would want myself. Baby, please believe me. I'll put you through hell. Just know me, yeah, yeah. So sure of yourself. Baby, don't get greedy. That shit want it well. Ooh, and well. He said I'm just curious. Is this for real or just an act? Can't tell if you love or hate me. Never met someone like that. Got me so crazy. Did you know you got that effect? I said, let me check, yeah. I would want myself. Baby, please believe me. I'll put you through hell. Just know me, yeah, yeah. So sure of yourself. Baby, don't get greedy. That shit want it well. Ooh, and well. I would want myself. People dream high in the quiet of the night. You know that I caught it. Bad, bad boy, shiny toy with a price. You know that I bought it. Killing me slow, out the window. I'm always waiting for you to be waiting below. Devils roll the dice, angels roll their eyes. What doesn't kill me makes me want you more. And it's blue, the shape of your body is blue. The feeling I got in it, it's a cruel summer. It's cool, that's what I tell 'em, no rules. Unbreakable heaven, but it's a cruel summer with you. Hang your head low in the glow of the vending machine. I'm not dying. We say that we'll just screw it up in these trying times. We're not trying. So cut the headlights. Summer's a knife. I'm always waiting for you just to cut to the bone. Devils roll the dice. Angels roll their eyes. And if I bleed, you'll be the last to know. Oh, it's blue. The shape of your body is blue. The feeling I got in it, it's a cruel summer. It's cool, that's what I tell 'em, no rules. Unbreakable heaven, but it's a cruel summer with you. I'm drunk in the back of the car, and I cried like a baby coming home from the bar. Said I'm fine, but it wasn't true. I don't wanna keep secrets just to keep you. And I snuck in through the garden gate every night that summer just to seal my fate. Then I screamed for whatever it's worth. I love you, ain't that the worst thing you ever heard? He looks so pretty like a devil. It's blue, the shape of your body is blue. The feeling I got in it, it's a cruel summer. It's cool, that's what I tell 'em, no rules. Unbreakable heaven, but it's a cruel summer. I'm drunk in the back of the car, and I cried like a baby coming home from the bar. Said I'm fine, but it wasn't true. I don't wanna keep secrets just to keep you. And I snuck in through the garden gate every night that summer just to seal my fate. Then I screamed for whatever it's worth. I love you, ain't that the worst thing you ever heard?
What's up?
Hi, Giraffe.
We brought you here today to let you know that we made the business decision to switch to ClickUp.
She's indecisive, she can't decide. She keeps on looking from left to right. Girl, come a bit closer, look in my eyes. Searching is so wrong, I missed the right. Like the time to love 'em and leave 'em and disappear right after the song. So give me the night to show you, hold you. Don't leave me out here dancing alone. You can't make up your mind, 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 mind. Please don't waste my time, 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 time. I'm not trying to rewind, wind, 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 wind. I wish our hearts could come together as one. No, shawty is a eeny, meeny, miny, mo lover. 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 Oh,
Let me show you what you're missing. Paradise. With me, you're winning, girl. You don't have to roll the dice. Tell me what you're really here for. Them other guys, I can see right through you. You seem like the type to love 'em and leave 'em and disappear right after the song. So give me the night to show you and hold you. Don't leave me out here dancing alone. Can't make up your mind, 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 mind. Please don't waste my time, 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 time. Not trying to rewind, wind, 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 wind. I wish our hearts could come together as one. two in mind. If you knew what I knew, it set your heart on fire.
Welcome back to IEEE 2024. Now we are continuing to the next agenda, which is our third keynote speaker, Mr. Husni Tamrin, PhD, moderated by Mr. Gunawan Arianto, PhD. To Mr. Gunawan Arianto, PhD, welcome to the stage.
Okay, thank you very much. This session we will have the third keynote speakers. So let's welcome Mr. Husni Tamrin to come to the stage. Please. Yeah, before we start the keynote speakers, let me share the curriculum vitae of Dr. Husni Tamrin. So Dr. Husni Tamrin has been lecturer in Informatics Department UMS, Universitas Muhammadiyah Surakarta since 2009. Yeah. He earned his PhD from the University of Glasgow in UK. Actually, her research during higher degree was in system modeling, but since 2009, his research has been in NLP, especially for Bahasa Indonesia. The research topic include text similarity using WordNet, text classification of SWOT, automatic scoring of short text and short essays, and assessment alignment with the learning outcome. Dr. Husni Tamrin also head of e-learning division in UMS. Basically, he in charge for the system in the learning division in UMS. He was also the previous dean of Faculty of Communication and Informatics UMS. Without further ado, let's welcome Mr. Husni Tamrin to present their presentation titled Indonesian Language Processing in Circular Assessment. Pak Husni, time and place is yours.
Thank you, Mr. Gunawan. Bismillahirrahmanirrahim, Bapak Ibu sekalian. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrahmanirrahim. Alhamdulillahirrahmanirrahim. Nahmadu wa nasta'inu wa nastaghfiruh. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma sholli wa sallim ala sayyidina Muhammad wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay, again, thank you for the committee to allow me to present my work regarding or on the topic of natural language processing. First of all, I would like to state a bit disclaimer. Yeah, a bit disclaimer. So among the three keynote speakers here, probably I'm the only one who is not a professor. Okay. So what I am talking this afternoon, probably a simple research, yeah, simple research. But probably I'm a bit lucky because I've got funding for my research, yeah. So I've been working on this topic about probably 10 years, and I've got several times funding from the RTPM. We call it now the RTPM. So what I'm presenting now is two of my previous research, yeah, regarding assessment or curricular assessment, atau dalam bahasanya penilaian, ya, penilaian. First about the assessment or scoring of short text, and the second one is scoring of short essay. Right. What I'm discussing now, first about a little bit about Indonesian language processing, and then what is it, circular assessment, and then next I will talk about the automatic scoring in assessment, especially for short text and then for short essay. Right, so what is Indonesia language processing? Well, actually it's natural language processing, but for Bahasa Indonesia. So my work is for Bahasa Indonesia, ladies and gentlemen. And Bahasa Indonesia is now also an international language, yeah. So if you attend an international conference like this and you talk in Bahasa, probably it's okay because it's also an international language, yeah. And studying Bahasa Indonesia, I think, is important for us because it's our language. Yeah. So, is it really different when we talk about natural language processing in general, or and language processing for Bahasa Indonesia? Actually, for if we look in the perspective of the algorithm, as far as I know, yeah, as far as I have studied so far, there is probably not any difference, probably, yeah. But the difference is probably about the data, yeah, the data. So for Indonesian language processing, of course, we study the object is Bahasa Indonesia, and then the second is the structure. Yeah, the structure of Bahasa Indonesia is quite different from other languages, especially English or probably Arabic. So what I found is that the study of Indonesian language processing is it becomes unique, yeah, because of the data that we process. And specifically for Bahasa Indonesia, we also find implementation, yeah, that should be specific to Bahasa Indonesia, and the results of the study may be different, yeah, from study on other languages, especially English. Right, then what is its curricular assessment? Maybe you can, next slide please. So curricular assessment is the activity in a classroom, yeah, where teacher need to give score to for the students to show the students' achievement. So in the end, or in the end of the study, a student will get a score from the teachers or from the lecturers, and that is called assessment. The way a teacher get the score is assessment. Okay, so this is then what I study, natural language processing for assessment. So what is so particular for, what is so special? Where is the implementation or the application of natural language processing in assessment? Well, if you give assessment to your students in the form of closed question, then probably you don't need any NLP, yeah, to get the score. But if you use open question, for example, a short text, short essay, or even essay, then probably you will need natural language processing for the scoring. Right, next please. So what is the short text, short essay, and also essay? What are the difference between them? The short text questions usually need probably 1 or 2 words, yeah, to get answered, or probably 1 phrase. Yeah. And this is then the example. For example, wilayah yang memiliki curah hujan tinggi sepanjang tahun dan ditandai dengan vegetasi hutan hujan disebut bla bla bla. Okay. So student probably need to write 1 word, 2 words, or 1 phrase to answer this question. Yeah, this is called short text questions. And to answer this question, student needs to write, yeah, not only needs to select, yeah, an option, but they have to write the answer. So this is what differs open question and closed question. For closed question, student probably can select among options, or probably they can use the mouse to fill in, yeah, to fill in the option, yeah. But for open question, they have to write. Next, for example, short essay questions. Yeah, this needs a longer answer, probably 1 sentence, 2 sentences, or probably 1 or 2 paragraphs. Yeah. The example of such a question is jelaskan konsep energi dalam sistem tertutup menurut hukum pertama termodinamika. Berikan 1 contoh aplikasi hukum tersebut dalam kehidupan sehari-hari. So to answer this question, students need to write, yeah, several sentences, probably 1 or 2 paragraphs. Yeah. And there is another type of open question that is called essay. For essay, students need to write much longer answer. Yeah, can be 1 paragraph, 2 paragraphs, or even several pages. Yeah. This is the example of such a question. Buat tulisan tentang pentingnya keanekaragaman hayati di ekosistem laut. Ya. Jelaskan peran ekosistem laut dalam menjaga keseimbangan ekologis global dan dampak dan seterusnya, and so on. Okay. So to answer this question, yeah, students need to write a longer answer. Yeah. Now, so why we give open questions to our students? I think, especially in university, yeah, most examination in university use open question, right? You here, most of you, I think, lecturers, or for students, you also experience where your lecturers give you question in the examination in the form of open questions. So what are the advantages of using open questions? Why we use open question? Well, there are many advantages of using open questions. Next slide, please. Next. Okay, here we are. Okay, the advantages of using open questions includes deep analysis and critical thinking. So students who answer the question has to think of what the meaning of the question, and then try to write answers, yeah, the answers. So if we compare with when students answer a closed question, yeah, probably they only need to guess, yeah, probably. Yeah. They only need to guess the answer of the question among the options available, yeah, A, B, C, or D, for example. But students can do that when they answer open question. They have to they have to understand the question first, yeah. They have to think of the question, and then they have to think of the answer and write something, yeah, to answer the question. So first, they have to analyze, yeah, the question and try to write the answer. So mostly they have to think of something, yeah, the analysis. So it belongs to higher order thinking skills. They have to analyze, yeah, probably evaluate the case, yeah, that is written in the question. And then student will showcase their understanding. When they are able to answer the question, it means that they understand the question and then understand the matter, yeah. Also, it induces originality or initiative, meaning that the student needs to write something with their own words, right? They need to write something with their own words. They have to understand the matter and then write the answer with their own words. So it induces originality and initiative. And also it's time efficient for the teachers, especially efficient in the preparation of the question. It's much more lebih singkat, ya, lebih singkat untuk membuat soal. On creating the answer, it takes less time rather than if they use closed question or for example multiple answer question. Yeah, if they use multiple questions, then probably they have to prepare tens of questions for an exam. Yeah, they cannot only make, for example, 5 questions. But if the lecturer give an essay question, then probably 4 or 5 questions are enough. Okay, and there are a lot more advantages of using the open question, yeah, like building structured argument, written communication, proficiency, minimizing guesswork, so student cannot guess the answer, encouraging good study habits, yeah, and also better retention, so that student remember better with the materials, yeah. But using the essay question also brings disadvantages, yeah. Several disadvantages include that assessment for essay answers can only be conducted by competent people, yeah, for the lecturer itself. Yeah. Well, you can ask your assistant to do that, but he should be also has a kind of understanding with the topic. Yeah. It's different if you make an exam with closed question, then probably your son or your daughter, yeah, can help you with the scoring, yeah, with the correction. But it's not the case for essay answer. And other disadvantages are examiner bias. So the scorer sometimes, not only sometimes, they are usually subjective, yeah, in the scoring. So if he knows the answer comes from, if he knows the student, for example, probably he will give a better score, yeah? And if no, and if the student, he knows the student is someone who he dislike, probably the score can be less, yeah. So there are examiner bias. And other disadvantages are, for example, scores can be unreliable because of inter-rater agreement. I will show you next, yeah. So one and another scorer can have a different judgment, yeah. Sometimes one judge that this answer is good enough, but the other say this is very bad, for example. It can happen, yeah, even for the same answer. And also halo effect. What is it? Halo effect is when you score for someone and then score for another, your way of scoring can be influenced, yeah, by the answer of the previous student. I mean, for example, if you first score for the answer of a moderate student, and then next you read the answer of another one which you feel better, then probably your scoring is not only based on the essential of the answer, but because of your feeling, oh, this answer is much better, so I like it, then I will give a good score for that. It happens, yeah. And other advantages include the limited content sampling. So if you give an essay question, probably you can only give 4 to 5 questions in an exam. So you cannot give question for a broad topic in your material. Probably you can only give answer for a limited topic, 4 or 5 only. So it does not sample the ability of the student in the whole. You're not quite comprehensive. So then poor predictive validity, also time consuming for both students and assessors. Yeah. It takes time for student to answer, and also it takes time for the lecturer to answer. So several of these disadvantages are tried to overcome using machine scoring. Yeah. For example, if we use machine scoring, we will eliminate examiner bias, right? We eliminate the halo effect, okay? And it can be efficient for the teacher, yeah? It does not take time for the teacher to give score, to assess. So that's why people try to observe, yeah, the possibility of machine scoring in to score essays. But machine scoring also give problems, yeah. Let's look at some example. Okay, first example, the scoring is conducted by a machine, yeah. So let's read the question and the answer and how the machine scores. Bagaimana cara menampilkan teks dengan skrip PHP dalam sebuah halaman HTML? So the student answer perintah echo atau print, and if you're familiar, I think, with this kind of answer, right? And you know that this answer is mostly correct if we don't say this is 100% accurate, but I think we agree that this question is very good, right? But see how the machine score. It says it does not correct, yeah, because the key answer is echo, yeah. So the machine expect the answer is echo, and the student write perintah echo atau print, and the machine says incorrect, right? So although I use as an application here that it says, it claims that it uses AI for the scoring, but still the good answer is considered. Oh, sorry, this one is correct, yeah. Oh. Yeah, okay, sorry. Yeah, still the machine says it is incorrect. The correct answer is echo, right? Another one, bagaimana PHP digunakan bersama dengan HTML dalam pembuatan halaman web. So the answer of the student is kode PHP diterjemahkan menjadi teks dan digabung bersama kode HTML yang lain. And the machine says it is incorrect because it expects the sentence, yeah, like this, that kode program PHP akan diterjemahkan menjadi HTML dan bergabung dengan kode HTML yang ada. So if we analyze the essence or the content of the two text, yeah, the correct answer, also the student answer, both contain the same meaning, but the machine says the answer is incorrect, and so on. So what does it mean? The machine at this point cannot correctly evaluate that the answer is good enough. Okay, so I think that's why we still need to do research, yeah, on how the machine can score better. Yeah, score better. What is the meaning of better here, or what is the meaning of good scoring by the machine? It means that the machine mimics human, yeah, in terms of considering the context, not just word by word checking, right? So the machine mimics human. That is the key, yeah. Now, let's look of some data of in one of my research here. So I survey 43 teachers. I asked them to score 20 short text answer, and look how the teachers scored. The 43 teachers score quite differently. Yeah? Their score is in the range of 0 until 4. Yeah. And among 43 teachers, there are about probably 3 teachers that give average score of 4, and about 3 teachers that give average score of 0 for the same answer. Yeah, for the same answer, 4 teachers says that, oh, the answer is all well, all very good, but 3 teachers says all the answers are bad. So I give 0 in average for those answers, right? So back to the expectation, yeah, for us, for the machine to give scoring, yeah. So we want that the machine mimics human in scoring, but unfortunately, humans are so so diverse, yeah, so diverse in the way to evaluate answers, right? Some teachers are harsh or strict, and some teachers are lenient. Okay, what about you? Are you belong to the harsh one or the lenient one? Jadi Bapak Ibu ini banyak ngasih nilai A atau banyak ngasih nilai E, kan kira-kira gitu ya? Ya, kalau untuk mahasiswa tentu senang dosen yang nilainya A semua ya, jadi yang grafik yang kanan itu, ya. But what are the ideal teachers? What do you think the ideal teachers? If you give all answer and you regard all answer are good, then probably the students will love you. Yeah, the students will love you, and they will be happy with you. But that kind of teachers, in my opinion, are not quite motivating. Do you agree with me? Not quite motivating. I mean, whatever the students do, they will get a good mark. Yeah. So they do something lazily, or they do their coursework diligently, they will get the same score, which is A. So this can affect the motivation. In my opinion, good teachers need to be able to differentiate the scoring based on the ability of the student. So good student will get good score, but yeah, average student get average score, and probably the bad one needs to take the course for another year, for the next year. Okay, that's in my opinion. So if we make a machine scoring, which human that we want the machine mimics or follow, the good one or the bad one, the good teacher or the bad teacher, yeah. Of course, I think we need the machine give the scoring like the average, yeah, average teacher. But probably you can make your system tunable. Yeah. So I will make a machine scoring, but I can tune the machine. Sometimes I want to make the scoring a little bit harsh or a little bit lenient. Yeah, maybe. So it can be a challenge, I think, that we can make an automatic essay scoring that can be fine-tuned by the teacher. Yeah. Okay. Another is survey. For this one, I survey 8 lecturers. Yeah, I was asking them to score about 1,600 and so essay answer. So for this one, the question is an essay question. Yeah, so it takes it needs answer, for student to answer, to write 1 or 2 paragraphs to answer. So the scoring is a little bit the same with the previous study. Yeah, there are lenient teachers and there are harsh teachers. Yeah, who give lenient teachers will give good marks. Yeah, for example, the teacher number 2 here, give scores to the student from 0 to 12. And the average score he gave is 10. So this one is a good teacher, according to students. But teacher number 8, gives score in the range of 0 to 8. And the average score is 3. Wow. Okay. So, it can be a challenge to make the machine scoring probably that tunable. Yeah. Okay, but for our study, I think we need to start with the average. Yeah, the average. I mean, teacher that give average score. Yeah. For example, in this case, the score range from 0 to 12. Yeah. So from the lowest score till the highest score, and the average is a little bit medium. Okay. Right. So, in my study, I try to formulate the machine scoring for short text answer and also machine scoring for the essay answer. For the short text answer, I find that of course, if the student give a correct answer, the score will be maximum. And if the answer is synonymous, not quite the same with the key answer, student will get also high grade, although the score is lower. Okay. If the student writes something and then it has typos, then the score is less. Yeah, the score is less. Also, the grade is less. Okay. For example, in this example, the key answer is pecah belah, and student write pecah belah, then most teachers will reduce the score. Yeah, reduce the score. And if the keyword is less in the letter, then the teacher will give a harsher penalty for the student, for the same typo. Okay, and if student answer with words that have some related meaning, then the score is much less, much less than if the error is just a typo. Okay, so the score in grade D in this example, the keyword is angkot, but student answer with truk, then it got grade D. And for unrelatedness, so the score is very low, in grade E. So what then I found is, if we want to formulate machine scoring for short text answer, then we can use this kind of flowchart. So we inspect the answer. If it's correct, then student will get the highest grade. If it's a typo, if you compare with the answer, then we reduce the score. If it forms a new word, and it has relatedness with the key answer, that then we'll give less score. Yeah? And if the word is unrelated, it doesn't get a score, meaning get a zero score. Okay, and if the student write a typo in his answer, then we can score using a kind of formulation like this. Yeah? So we consider the edit distance and also the length of the letter, the length of the word. Yeah? How many letters the word is.
Sorry, maybe the slide need to update. Sorry, slide, can you update the slide?
Okay, sorry, please, next slide, please.
Yeah, looks like it's frozen. Next slide, please.
Next. Next, yeah, this, yeah, this one, please. Yeah. Okay, so maybe the sebelumnya, yeah. Okay, this is the formulation, yeah, of machine scoring for short text answer. Okay, and next, please. For the typo, we can use this kind of formulation, yeah. So we consider edit distance and also the word length. Right. Okay, please, next, please. Okay, for machine scoring, if the answer has some relatedness with the key answer, yeah, the students have a kind of relatedness with the key answer, then previously I tried to calculate the score using WordNet like this, but what I find, because in Bahasa Indonesia WordNet is so limited, yeah. So in the case of our language, we have a so limited data set, yeah. I think in many occasions, in many fields of NLP, yeah, either for sentiment analysis or for post tagging and so on. We have so limited resources. This applies also for the WordNet. Yeah, our language has about probably 30,000 words, but we don't have this kind of WordNet. Yeah, so if we want to use this structure to calculate the score for the relatedness, it's very hard for us to get the formula, yeah, because of unavailable data. Yeah. Next, please. Okay. For some years ago, people introduced what is called BERT-based models, yeah, and it is declared that this model can find the semantic relation of one, can calculate, yeah, the semantic relation of one word with the other. So I tried, yeah, to make a formulation to do machine scoring using this model, yeah. And next, please. And the result is this one. So using Cahaya BERT-based model, I get a machine scorer that has agreement with the human scorer, yeah, with the Cohen kappa value 0.1127, meaning the agreement with human is poor. For BERT model, although it is claimed that it can calculate the semantic meaning, yeah, the semantic relation between one word and the other. So, and we use it in machine scoring for short text answer. The agreement with human scoring is only 0.1, yeah. So it is poor. And I tried another BERT model, yeah, using Denaya Indo as BERT large, and it gives a better agreement, which is a 0.2, yeah, belonging to a fair agreement. But also I think it's not yet reliable. Yeah? It's not quite similar to human scoring. Okay, next please. And then because recently we are introduced with large language model. I'm interested to try that. Yeah, so I try ChatGPT 4o. Yeah, I ask the model to score the short text answer. Yeah, and I find that. Okay, next please. Yeah, one more. Okay, that's the prompt, yeah. The prompt that I use to ask ChatGPT to do the scoring. And then the result, next please. This is an example of the answer of GPT. And next please. And this is the agreement. So large language models, it's much better, yeah, in performance than other language models so far. Although the agreement belongs to the range of moderate, so if we use it, if you really use it for scoring short text, it's not, maybe it's not yet reliable, yeah, not yet, but probably closer. And maybe if we can have a larger language model, it may result in a better agreement. And maybe sometime in the future, maybe next year or 2 years, 2 years from now, we will have a language model that can help us do the scoring. And similar experiment, I do similar experiment for short essay, and let's go directly to the result. Next, please. Next, 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 next again. For the BERT model, for BERT model and cosine similarity, kappa is 0.1. And then next one, please. If we use a large language model to score an essay answer, the agreement with human scoring is 0.45. This agreement is lower in value compared to the short text answer, but it also belongs to the moderate range. So not yet reliable to use in scoring, yeah. Although if you search Google, yeah, some people has claimed that, oh, ChatGPT is very good enough to help us in scoring essay answer. But in my experiments, yeah, trying to mimic, to compare the scoring between model and human, the agreement is not yet high. So not yet reliable, but probably we will have a better model in the future. So we can rely on AI to do lecturer's task. Gitu ya Pak Kusban ya. Nanti suatu ketika kita akan bisa menggunakan AI untuk membantu kita mengoreksi jawaban mahasiswa. Jadi UAS mahasiswa itu bisa di-scan, menjadi teks dan kemudian dikoreksi oleh ChatGPT, kemudian sebentar saja selesai. Khususnya kalau jawabannya adalah dalam bentuk teks ya, tapi kalau jawabannya dalam bentuk gambar atau mungkin formula ya. Nah, kalau misalnya soalnya tentang penggunaan formula atau matematika mungkin belum, tapi kalau teks mungkin sudah. Barangkali itu saja. That's all from me. Hope what I present is can give you some insight. Yeah. Thank you.
Thank you, Dr. Husni. Let's give applause to Dr. Husni. Okay, it's very interesting topic. Yeah, so based on Dr. Husni research, the current LLM is not good enough. The ChatGPT 4.0 is the best at the moment, better than BERT at least, but still, yeah, the score is 0.5. Okay, I think it's now I open the question session for the audience. Please, if you have any question, you can raise your hand in the Zoom or in the meeting room. Yeah, time is yours, okay. Anyone from this room? And from the Zoom? Okay. While waiting, because we still have 10 minutes, don't worry, no rush. While waiting for the other question, maybe I want to ask Mr. Husni. So this research is basically limited to Indonesian language, right? And the LLM that you use is ChatGPT 4.0 and BERT. Have you tried another LLM, for example, from the Meta, like Llama or the others? Yeah.
Well, to tell you the truth, I have not tried other LLMs, but I want to ask Gemini. Yeah, I asked Gemini, and my question is: can you score short essay answer? And it says no. It directly says no. So I leave it.
Straightforward.
I will leave it.
Okay.
And when I ask the same question to ChatGPT, it says yes. I can help you. Please tell me the question, tell me the golden answer, and if you have a rubric for me to follow, then tell me. I will help you. So in this case, I try ChatGPT.
Okay, yeah. Thank you, Pak Husni. So even the Gemini like give up when you try to ask. Did you ask in Indonesian language or in English when asking Gemini? When they give up, yeah. So because in English should be it's very mature, right? The current ChatGPT and Gemini to answer kind of essay or short question, yeah.
Usually for first communication, I use English. Yeah.
Oh, okay.
To ChatGPT or to any LLMs, my first communication is English. And then if it says positively, then I will use bahasa.
Bahasa Indonesia.
Yeah,
Okay.
bahasa Indonesia. So because I think we can regard that the model understand more English language, yeah,
Yes,
rather than, for example, bahasa Indonesia, because it has a much larger data set, yeah, much larger collection of data, so it can understand more if we communicate with English.
Yes, Yes, Dr. Husni. Okay, for the audience and attendants, do you have any question for the keynote speaker? This topic is very interesting. If you know, like, this is not only about research, but also the application. I think in the outside, maybe some application, especially SaaS applications, software as a service, they try to offer this kind of services, Pak Husni. I'm pretty much sure there is, yeah. They can help you to automatically, assess the essay, and also another another assessment maybe. Not only maybe text, but also I think they can also read image as well. Yeah.
Yeah, sometime. Because I also I once tried the LLMs to give some analysis. So I give him a table and I ask him to give evaluation with the table, and he can answer. He answered with he tells the trend, he tells about the some points in the table. So at that time I tried whether the LLMs can help us in writing a scientific article. Yeah.
Okay.
So for example, if we have data, we have this table, and we don't have to write the evaluation and ask the LLMs to do so, and they are able to do. And even I tried to upload a graph. Yeah, I upload a graph, and then I ask LLMs to give a description about the content of the graph, and it also able to do so.
Yeah, it's like IELTS.
At least if you feel enough with shallow analysis, yeah, then LLMs is sufficient. Jadi kalau misalnya mau nulis hanya untuk mungkin Sinta 4, Sinta 5 sudah bisa. Pakai jadi nggak usah mikir.
Okay, we have question.
Kalau Sinta 2 dan Scopus mungkin ya perlu ya.
We have question from the audience.
Yeah. Okay.
Okay.
So, okay. Thank you, Mr. Husni. Interesting topic. One question for me. What if the model is in next year maybe, can the model used to evaluating another assessment, not just simple assessment like what in the presentation, but another case like assessing presentation that affecting any other aspect like linguistic variable or another. Jadi,
so the question is in 1 year, whether the model can have the ability to not only check the assessment like short essay or essay, but also more than that one, Pak Husni. What do you think about that one? Yeah, because ChatGPT is something that you can, give input and anything, not only text but also image, text, and anything. Yeah.
Well, I have not tried yet. Yeah, I have not tried yet. But for the text question, actually ChatGPT give you not only the score, in this case, but it also give the reason behind the score. So I can give you, I cannot display my laptop, right? So, okay, I will give you a short example, yeah? So, okay, I have a question like this for the short text answer, right? So the question is, kemajuan teknologi informasi dan bla 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 telah membuat dunia semakin terasa kecil. Setiap kejadian di pelosok dunia dapat diketahui dengan cepat oleh semua orang. Okay, the answer for bla 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 is komunikasi, right? Teknologi informasi dan komunikasi. And the student answer is komutasi. The student answer komutasi. So how ChatGPT give the score? It first explain. So it doesn't. It does not just give you, the score is this number or this range. No, but it also give you the evaluation. So it says like this. Kriteria yang sama akan digunakan, tepat 4 jawaban siswa persis sesuai dengan kunci jawaban. So it tells you the criteria, how ChatGPT score the answer, right? So there is a score 4 until 0. And then it also gives evaluation. konsep kunci jawaban komunikasi berhubungan langsung dengan penyebaran informasi yang cepat dan globalisasi. That's what ChatGPT says. And jawaban siswa komutasi adalah istilah yang secara teknis terkait dengan switching dalam elektronik. Oke, atau telekomunikasi, tapi tidak memiliki makna yang tepat dalam konteks kalimat yang diberikan. So, nilai yang diberikan 1. From 0 to 4, ChatGPT gives 1, but it gives the reason behind the score, right? Okay, and it explains more, ya. Jawaban komutasi adalah istilah teknis yang berhubungan dengan teknologi, namun tidak memiliki relevansi yang tepat dalam konteks kalimat yang membahas kemajuan teknologi informasi dan komunikasi. Ya. Kemudian meskipun komutasi memiliki sedikit hubungan dengan teknologi, penggunanya dalam kalimat ini kurang tepat dan tidak mengkomunikasikan makna yang dimaksud. That's what ChatGPT says. So it can be better explanation rather than your teacher. Sometimes, or maybe oftentimes. Right? Is that correct? Ya. Dosen jenengan tidak akan mengatakan hal seperti ini kepada Anda, ya kan?
Iya.
Kenapa dia memberi skor 1? Tidak akan menjelaskan seperti ini, ChatGPT memberi dan cukup memuaskan. But my research is to observe whether there is an agreement between LLMs, ChatGPT, and human. So, and I found that it's not yet, it has agreement, but not yet high. Okay, that's it.
Thank you.
Okay, thank you very much. Okay, due to time constraint, I think we have to finish this session. Thank you very much again for all of the audience and also for the Dr. Husni Tamrin. Yeah, let's give applause to Dr. Husni Tamrin. Yeah. Okay, thank you very much. That's all from me. I will give the stage back to the MC. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Husni, for the material, and as well thank you for Mr. Gunawan for moderating the previous session. All right, moving on to our next agenda, which is a parallel session that we will be reading out for each room.
All right, room 1 for machine learning will be moderated by Pak Isman.
Room 2 for smart computing will be moderated by Pak Sukirman.
Room 3 for Internet of Things will be moderated by Pak Ulin.
Room 4 for machine learning will be moderated by Pak Dedi.
Room 5 for smart computing will be moderated by Pak Yusuf.
And room 6 for machine learning will be moderated by Pak Kusban.
For all of the participants, you may head to each of your room and there will be LO that will lead you to the room.
Thank you.